Okay. All right, good morning everyone. Today we are going to do analysis of basic radicals. That is there. Okay. Now when you talk about basic radicals and acidic radicals, the very first thing that you think about is what are they? Anions are your acidic radicals, and all your cations that you actually do are your basic radicals. But why anions the acidic radicals and cations the basic radicals? The reason for that is, like, just think about any salt. The basic salt, and my favorite example that I normally take is your NaCl. Alright. Now in NaCl, when you think about it, it is like nothing but having Na plus as the cation and Cl minus as the anion. Right. Now in this, Na plus is coming from the base. Na plus is coming from the base. So we call all the positive ones the basic radicals, and your Cl minus is coming from the acid. So that is why, since your anions are generally coming from the acid contribution, that is why whatever anions that we do with a negative charge are taken as a part of your acidic radicals, and whatever cations we have with a positive charge are taken as a part of your basic radicals. So no confusions about that, because normally you talk about the salt analysis, that is the analysis of the cations and the anions. You generally do not talk about acid radicals, basic radicals, but you should know that when you talk about the qualitative analysis of acidic radicals, we are talking about the anions. A for acidic radicals, A for anions, so AA, and then whatever is left over is for the next basic radicals is for the cations. Okay. Now whenever you get a salt mixture, the very first temptation that you have is to consult your friend as to what it may be. I don't know if you've started doing it in practicals, must have. So in that case, whenever we start with it, let's start up with it directly. Can I have the duster, please? Okay. So as soon as you get your salt, the very first thing that you observe is the color. Okay, based on the color you get several indications as to what your cation or anion may be, because there are some salts, and if you get a colored salt, then that means you're very lucky, because it is very easy to designate your colored salts. They're very color specific, but if you get a white one, then it can be a mixture of any cation with an anion. So let's talk about the color first. Like for some of them, like if you have a blue or a bluish green color, if it is blue, then definitely it's copper, and if it is bluish green, then it may be nickel as well. You have Cu2 plus if it is blue, and Ni2 plus if it is a little bluish greenish tinge with it. So if you have absolutely a greenish tinge, then in that case there's a particular color for nickel, and that will be for Ni2 plus. If it goes, I mean, this is like the normal green. If it goes lighter than the normal one, then light green is for your Fe2 plus. So you know that if you now get something in green, it may either be Fe2 plus or it may be Ni2 plus. Okay. And then you have dark green color. Dark green is very peculiar for chromium ions. Okay, generally not given at the school level, but you should know dark green is for the chromium ion, because when you get MCQs you get color indications and you will be asked to actually talk about them like that. Then you have a light pink. This is a very common one which is given, light pink or flesh colored salt. Flesh color is due to the presence of Mn2 plus, that is due to the presence of manganese 2 plus. And if you have a dark brown color, dark brown is when your Fe2 plus is oxidized to give you Fe3 plus. Okay, and that's it for the colors as far as you could get. I have just jotted it down on the board, and just remember the colors. The moment we talk about the color, is it visible now? The moment we talk about the colors, the very first indication I am telling you for the analysis means that you are given some kind of a powdered salt or a normal salt. even if it is like in specks, you're supposed to crush it finely so that you can prepare the OS properly. OS is your original solution. Then what you have is, we talk about the blue or the bluish green. If the color is that, then it may be either copper or nickel. Learn it right here, right now, because this is like an easy thing that you can remember. And when you perform it again and again, as it is, you get thorough with it also. Then if the color is greenish, it may be either nickel or it can be actually Fe2 plus. Then in that case, if you have a green, so you have a fix between the two. Let me tell you, generally light green color is less available because your Fe2 plus when kept in nature generally gets oxidized to Fe3 plus the moment you put it in solution. So generally this is like also comes in combination with this. Dark brown color is Fe3 plus. Then dark green color for chromium, and light pink or flesh color is for manganese. So you should be able to make out for these salts right at the first go itself. And then there are some salts like lead sulfide, which may be dark grey or black in color. Depending upon that also you can actually demarcate about the cations and the anions. But as of now, if you're getting a colored salt, one thing is clear, you can just get an idea about the cations from it. Okay, next we can also talk about the smell. See, the moment you get the salt, you can even smell the say either the solution or the salt as it is also sometimes actually give you a kind of a peculiar kind of a smell. Like if you get an ammoniacal kind of a smell, ammonia smell is very peculiar, so that indicates the presence of ammonium ions. So remember that another demarcation, these are very first initial preliminary things that you actually try out. One is ammoniacal smell. If you have an ammoniacal smell, then in that case ammoniacal it is called, then in that case you have NH4 plus. If you have vinegar kind of a smell, then it indicates the presence of your acidic radicals, that is the acetate ions. Vinegar has acetic acid only, so you have the presence of CH3COO minus. For all those of you who say that we do not get to know about the smell, just go to your home kitchen and just smell vinegar once. You will get an idea that what kind of a smell it has. Okay, and then you have smell of rotten eggs. This is also very peculiar. You will be able to make out, and this is for your sulfide ions. Okay, these are some of them. Then I think we can even perform the flame test. We can even perform the flame test, and for the flame test what you generally do is you actually can take up a glass rod and dip it in your say just add a little bit of salt to it, and then you bring it to the flame. You have the Bunsen burners, all of you all in your labs. So what you can do is you can just take a rod, just let your rod touch your salt in such a fashion that it just gets attached to it, and then you just want to heat it directly to the flame. Now when it is burnt in the flame, there are some characteristic salts which give wonderful colors which are like characteristic for their presence. So that is like if you do a flame test, then you can have if you get a brick red flame, then in that case you have a Ca2 plus. You can demarcate the colors very easily. That is Ca2 plus. If you have a crimson red color, crimson red is the normal, the proper red. Okay, brick red is a little darker than the crimson red. So what you have is crimson red, then it is strontium. Anyways, both of them belong to the same group. So, and then you have grassy green for barium, for Ba2 plus, and then you have bright bluish color, that you know, very bright blue color, that will be for copper. Okay. So now the moment you're going to get the salt, what are you going to do? First of all, look at its color. If it is a colored salt, then you know it is either going to be copper, iron, chromium, or it can be manganese. If it is pink color, tell me which iron? Manganese. If it is green, nickel or Fe2 plus. If it is bluish green, nickel. If it is blue, Copper. This you can remember in just one go, so do not have to put any extra minds for that. And you have to remember why do you have to remember it? You have to remember it only from for the entrance point of view. Otherwise, for practicals, I think you're generally allowed to carry the scheme. Are you all allowed? No, not allowed. Otherwise, in sciences, generally we do not lay emphasis on mugging up things, but rather we allow you to just go through, and the main thing that comes out of it should be, because as chemists, see, whenever you are doing something, as chemists, what is your responsibility? Your responsibility is to give the chemical analysis of it. So whatever comes out of it, you should have a chemical explanation for that. Otherwise, anybody who is not even related to sciences can just follow the scheme and perform it. That's not that big a task. But what is happening inside is what is more important for you. So anyways, as of now, initially it is always good to learn, so that when you grow up it gives you a lot more confidence in sciences. Okay, now we start with the basic radicals directly. Remember that in basic radicals it is generally divided into 6 groups. You have group 1, 2, 3, 4, 5 and 6. Alright, in this there are some group reagents in general. Those group reagents also you must be familiar with, as you have performed. Before starting up with all the group 6, sometimes it is called a group 0 for the ammonium ions. And in some of the books you will find it in the group 6 also, because it is like a separate test. What is the special feature about them is like you directly add the reagents to the group 0 or group 6 elements, and what you get is the direct confirmatory test. For the rest, you can first get an indication, because we've grouped the ions together, and then we can perform the confirmatory test to make sure that that is there. And please do not leave ever your tests at the indicatory stage. So how do you go about doing it? Let us first note down the ions which we can actually get. First of all, note down, make a small table quickly from group 0 to group 6. What we can have is, we can have groups. Here, let me just put it. The radicals here, and say the general reagents, the group reagents here. Now, if I am talking about group 0, then I am talking about, say, NH4 plus. And just to remind you, it can either, again I am telling you, group 0 in some of the books is mentioned along with group 6. Now here what you generally do is you add NaOH. When you add NaOH, suddenly there are a lot of fumes which come up which are colorless. And these fumes are something which are due to the presence of ammonium ions. So what gas it may be? Ammonia. So naturally it will be ammonia gas, and let me tell you, you're always suggested, this is like a precaution that you all must be taking, even in your practicals, whenever you say you get a salt, supposedly ammonium is present. It's the easiest that you can get because your work is done right at the first go. But some of the students forget to add it, and then they go with 1, 2, 3, 4, 5, 6 and get nothing, and then they go to the teacher saying that we did not get anything at all, ma'am. So you check what you've given. So it is like that, you always should perform this ammonium ion test right initially. You add a little bit of NaOH to it. Sodium hydroxide add karoge, so immediately you will get ammonia will be expelled. The only thing is, you should always say, if this is your test tube, you should always be smelling any of the gases that you want to smell from a distance in this fashion. Alright, you should always be taking whatever is it's like a precautionary measure that should be taken. You should never inhale the gas that is actually being emitted out, because a lot of ammonia can cause headache. So these negative points should also be remembered. If you actually inhale a lot of ammonia, it will cause headache, which will be problematic. So it is always beneficial, and sometimes some students complain that our nose was choked or blocked, so we couldn't smell it, ma'am, we didn't know that it was indicatory. So the best thing is, you add to your salt solution, or normally to the salt also, add Nestler's reagent. Okay, that will immediately give you the brown precipitate. That is confirmatory for your ammonium ions. That's the best thing to do. So I suggest, even if you, because for some students, if they do not get anything, they say shayad it is ammonia ka smell only, if not anything else, because then they start, you start imagining. That is the problem when you perform it in practicals. I mean, this is like experience till date, that students, even if they're like not get anything, they will look at the color that they think may be present. So they will say that this looks like pink, na? So they will look actually at the color and just start imagining things. That is not to be done. So remember that group 0 is like ammonium, We'll talk about each one of them in details. Then group 1 में we'll do PB2 plus, and we can also have AG plus. Then in group 2 we can have AL3 plus, FE2 plus. I'm just keeping it basic abhi with whatever is to be done in your according to your CBSE course. Otherwise you have very many salts mixtures which can be given. AL3 plus, FE2 plus, FE3 plus. Then in sorry, that is for group 3. I just wrote, sorry. Group 2 is your P plus, Hg2 plus, you have Cu2 plus and cadmium 2 plus, because it may sometimes so happen that your Pb2 plus may not be precipitated out in group 1, so it again may come out in group 2. So that is why we write Pb2 plus in group 2 as well. Then in group 3 we generally have Al3 plus and Fe, the one that I just wrote by mistake, Al3 plus, Fe2 plus and Fe3 plus. Then in group 4 we have Zn2 plus, Mn2 plus, CO2 plus and nickel. Group 5 is barium, strontium, calcium, strontium and barium. And group 6 you have Mg2 plus, and sometimes, as I told you, ammonium is like mentioned here in the notes that I've taken. Okay, the general reagent that you add for ammonium ions is your simple NaOH solution, right? For the first one you add dilute HCl, right? Then you add for the second one as dilute HCl plus H2S gas is passed through it. Then for the third case you add NH4Cl solid plus NH4OH solution. Then you have in the next case NH4Cl solid plus NH4OH solution plus you have H2S gas. In group 2 and group 4 you pass H2S gas. And then in group 5 you have NH4Cl plus NH4OH plus ammonium carbonate. Okay, ammonium, NH4 twice, CO3. And then magnesium again is like a direct confirmatory test, so we'll just discuss that. Fine. Now just understand the methodology once. What we do in this is, we take group 0, like for example, the very first thing is you get your salt, you do whatever elementary test you can do, but all those tests are only indicatory till you do a confirmatory test. So chemical analysis has to be done. You have to move to the wet tests. These are called wet tests because you're taking solutions in each of the cases. So in this case, the group 0 I've already discussed briefly. Then in group 1, what do? You take your salt solution. Alright, if you were able to prepare your salt solution very well, and then add dilute HCl to it. If you get a precipitate, wonderful, your work is done, because you will be given only one cation and one anion to analyze. So if you do not get a PPT, please do not throw that solution. I repeat, you've taken your test tube, you do it in a 15 ml wala test tube. Otherwise, normally at higher stages of studies, it is done in semi-micro analysis. So those are the small test tubes which are taken, this small. And you generally do it in this big, right? So now what you do is you add to your salt solution dilute HCl. You are not getting any precipitate. If you're not getting any precipitate, means your first group is absent, because each one of them is associated with a precipitate only. Now we move on to the second one. In the second group, when we move on, you do not have to throw the solution. मान लो whatever solution you had taken, उसमें क्या डाला? Dilute HCl. अब dilute HCl से कोई precipitate नहीं आए, do not throw it. Just take it to the H2S pump and pass H2S gas through it. Make sure that the knob of the H2S that you're dipping in should be clean. Because if the previous student who had used that pump had some cadmium in it, then in that case that little bit of precipitate added on to the nozzle of the gas passing tube, to the nozzle which is to be put inside, if that is like having a little bit of speck of the cadmium sulfide also, it will give you a yellow color, and then you will be in a fix whether you had cadmium or not. So remember that, or any other precipitate. So remember that what you have to make sure is that, make sure that before passing the H2S, you dip the apparatus of the H2S first in normal water and then into your solution which contains dilute HCl, which you had added for group 1, and now simply pass H2S gas. Now if you get a precipitate, then we'll go into the details for group 2. Otherwise, now we have to move on to group 3. So throw away your solution now, because now dilute HCl and H2S was added. So now in the next, because the reagents go different, so please make sure, now what you have to do is, now group 3 is very important. Whenever you perform group 3, make sure that first of all, whatever salt you have, you prepare a solution of that and add NH4Cl to the extent of saturation. And how do you make sure that it is added to the saturation? You know that the test tube becomes a little cooler whenever you perform this test, if you've done it sincerely. You take the salt in the test tube, shake it vigorously, salt solution ban gaya. Now add NH4 with the help of a spatula. You add NH4Cl, mix it. Do not hesitate, nothing will happen to your thumb. You can just put it, shake it vigorously. Alright, ideally you should not be touching it, but then you can just shake it vigorously, make sure NH4Cl gets dissolved. If it is getting dissolved, add more. Dissolve, add more, till you get a 1 speck extra of NH4Cl, which will make sure you've added NH4Cl sufficiently. Clear with that? You have to make sure that NH4Cl has been added sufficiently to your solution. Once that is done, how will you make sure that whenever an extra speck is coming which is not getting dissolved further, that means the saturated solution is now obtained. Or else if you get some extra, say 1 full spatula is added and that is not getting dissolved, then I ask students to take up the supernatant separately. Take the liquid separately and let that, whatever is getting settled down, let that be separate. So you are interested in the saturated solution of ammonium chloride. Then add ammonium hydroxide to it. This is the correct way to make sure that none of this gets missed. Aluminium and iron do not get mixed in your group 3 analysis. If you prepare a saturated solution, why is it important? Because in this case, you also see that NH4Cl and NH4OH have something in common. What is that? Ammonium ions, and that is your common ion. So we'll talk about that also, and you have in this case the common ion effect predominating. So we want to make sure that there are sufficient amount of OH minus ions to just precipitate the hydroxides of aluminium and iron. Clear with that? Next, if you do not get any in group 3, then what we do? We add if you are not getting any precipitate, again you do not have to just throw the solution. Just take your solution and now pass H2S to it. Again you have to follow the same protocol. Make sure that your gas or nozzle of the apparatus is clean enough when you dip it in your test tube. So when you actually now pass H2S to it, if you get any precipitate depending upon the colors that we'll just discuss, then you will have group 4 present. If it is not there, then just discard it. Now discard it because it has H2S. You could have prepared this sufficiently to divide it into 2 parts. 2 parts क्यों बोल रही हूँ मैं? क्योंकि एक part में H2S pass करो. If you get a precipitate, that means your group 4 was present. If you do not get a precipitate, directly add ammonium carbonate to it now. Because group 5 reagents क्या है? You have NH4Cl, NH4OH and ammonium carbonate. So now add ammonium carbonate to it, and just in case if you get a white precipitate again, then in that case it may be either calcium, strontium or barium. And last May, if nothing is coming up, you can only hope for the group 6 to be present, magnesium, for which you can directly perform the test of magnesium. I repeat, we have just discussed the analysis, not the analysis, just the preview of what we are going to do in the salt analysis. The moment you get salt in your hands, you will get, if it is a colored salt, you know that it may be copper, nickel, chromium, iron, manganese, etc. If it is a white colored salt, you see the absence of all these salts. So do not report them also, because normally these are not white. Okay, so if you get a white colored salt, anything apart from this, so half work is done, you get an idea. Then you can even perform the flame test, and there is a borax bead test also that can be performed. We'll just discuss that as well. But first, let us just talk about the analysis scheme that we just discussed. These are the normal reagents and the normal protocol which needs to be followed. And once you get the precipitate in any of the groups, then we'll move on to do the confirmatory for that. Without any indication, there is no point performing the confirmatory test for each of the each of the ions that you get. For the first case, we add NaOH. Smell of ammonia will be indicatory for your ammonium ions. Then for the next case, we add dilute HCl. Second group, we add dilute HCl plus H2S. Next case, we add NH4Cl and NH4OH. Then pass H2S to this. Fifth, add ammonium carbonate to group 3 wala reagents, and you will get whether or not you're getting a precipitate. So now let's discuss the chemistry behind all of these. See, for the first case, you can even write down the reaction of any of the ammonium salts. Say, if you want, you can write NH4OH plus NaOH, and then try and make it out for yourself as to what will it give. Say, if you have the very first one, we are talking about the test of the basic radicals, wherein we are taking salt plus, I am discussing ammonium ions presently, plus NaOH solution. And if there is a need, still you can heat it, because sometimes ammonia may not be coming out. You can just heat it to get the smell. So you can just heat it, and if you heat it, then there is a colorless gas. What is your observation? The observation is that you may get a colorless gas with a pungent smell. The smell is so pungent that I suggest please never ever put your nose directly to it, otherwise you will develop a headache. And it is always beneficial to have a coffee or tea after that. It helps your radicals settle down. So you have colorless gas and then with a pungent smell, and then in that case we say that ammonium may be present, because smell criteria is not the criteria for judging. So then what you can do is, you can expose a glass rod dipped in concentrated HCl to it. Expose a glass rod dipped in HCl to the gas, alright, and you will get dense white fumes. You will get dense white fumes now. Dense white fumes, because the fumes get enhanced. And remember that if you get a moist litmus paper to it, if you get a moist red litmus paper, say red litmus paper, then in that case, you know, bases, what do they do? You remember BRB? Bases turn red litmus paper blue. So if you have a base coming out, it will turn your red litmus to blue. So then in that case, your moist red litmus paper will turn blue. All these are just indications. And when you actually perform a reaction, then in that case you can say that's the confirmatory. So now let me just talk about what is a pungent gas. Pungent gas is something which is like very troublesome kind of a smell. Pungent means which is very strong and simultaneously very irritable smell. Then what is the base of this group classification? See, the base of this group classification is just dependent upon their properties of getting precipitated out. See, whenever we talk about the group analysis, this is like a good question. Whenever we talk about the group analysis, we always get a precipitate. ठीक है, फिर अब precipitate में there is a particular criteria as to what am I actually studying. Say if I am talking about any salt, let's go into the chemistry of it. If you have any salt like AgCl, which is like solid, understand this if you've done kinetics. AgCl will give you Ag plus Cl minus. All right. If this reaction is like sparingly soluble salt. So in this case, if I write down the equilibrium if I write down the equilibrium constant for this, what will that be? That will be Ag plus in aqueous media and into Cl minus upon AgCl. All right, and that multiplied upon AgCl solid. When I take that AgCl solid here, that means my K into AgCl solid. K is my equilibrium constant. That into my AgCl solid will be my solubility product. No, that will be, I mean, just let me, that is be your solubility product. Now solubility product is like this Ag plus and Cl minus remain dissolved in the solution itself. And there is something which is like known as the ionic product. Ionic product is like whatever concentration is extra. You get the point? So now there is a relationship between your solubility product and your ionic product. If your ionic product is like, this is the concentration that one would expect, and solubility product would be a constant for a particular salt. Okay, what is our intention is that we want somehow the Ag plus concentration or Cl minus concentration to go high, such that ionic product means this ion concentration into this ion concentration. Simple. But what is your solubility product? It's like constant for a given salt, some kind of a factor which is associated or characteristic of a given salt. So then in that case you have Ag plus into Cl minus, that is equal to K into AgCl solid. So I call it the solubility product. And what is your ionic product? That is nothing but Ag plus into Cl minus simply. So this can also be called the ionic product, but ionic product refers to the product of the concentration of ions which are actually existing in the solution at a particular point in time. So if I increase the concentration of Ag plus or Cl minus, तो क्या होगा? It will precipitate out. The moment एक भी concentration किसी का भी बढ़ेगा, so it will get precipitated out, because solubility product means as long as you're remaining within that solubility product area, till that time it will be soluble. The moment you exceed that, it will be precipitated out. So our idea to find out whether a particular thing is present or not is to exceed its solubility product such that I get a precipitate of a given group. And based on that, we have segregated these groups according to that. So as if now you are supposed to remember as to whatever ions are associated with each of the groups. And what are the ions which are associated? We just discussed. For group 0, tell me quickly as I rub the board. Group 0 is your ammonium, and we were doing ammonium only. And then group 1 is your lead and Ag plus. Then you have in group 2, what all? Pb2 plus, Cd2 plus, tell me, Ag, and then you have copper 2 plus also, and group 3 you have aluminium and iron, group 4 you have zinc, manganese, what else? Cobalt and nickel, and group 5 you have calcium, strontium and barium, and group 6 you have magnesium. So you are supposed to remember that. What is the deciding factor of group in different groups? And this is what the first and the second questions were just talking about. So remember that somehow we need to make sure that the precipitate comes out in such a fashion that it does not interfere with any of the other groups. So in this case, what we did talk about is we were talking about the confirmatory test of ammonium ions, and that is what you do is to the original solution you add Nessler's reagent to it. Nessler's reagent. Okay, now first of all, I did talk about the salt plus NaOH solution. I had written, now I've rubbed it by mistake. What you had was salt, you add NaOH solution, you get a pungent smelling gas, and that gas is ammonia. So you can easily try writing down the reaction on your own, and I think if you have confidence in yourself, I think you can just make an attempt to write the reactions first before even learning them up. Say if your salt was NH4Cl, what have we done? We have passed NaOH to it. So what will get liberated? You know, ammonia will be liberated. The rest of the reaction can just be balanced. NaCl plus H2O. Alright. Now if I am adding Nessler's reagent to it, remember that the formula for Nessler's reagent is K2HgI4. There are certain things that you need to memorize. You have the Nessler's reagent as K2HgI4. Repeat it. K2HgI4. Be more vocal. Breakfast किया सबने. So what is it? K2HgI4. K2HgI4. अब इसके अंदर क्या जाएगा? What you add is like you have the original solution with ammonia. That ammonia reacts with the K2HgI4, along with you add a little bit of base to it, because the base needs to be added to it. So what you have is you take your solution, add salt, may you have added NaOH or KOH, that's like one and the same thing. Now in majority of the cases, this is like a question not asked generally. Why do we refer to sodium salts more than the potassium salts? Because potassium salts are more expensive. So otherwise, so that is why we refer to, in majority of the cases, you will find the sodium salts everywhere and not the potassium salts. So just the reaction with potassium. So that will give us a kind of a precipitate which has the formula H2N double bond HgO dot HgI. This will be a brown colored precipitate plus 7Ki plus 2 water. Alright, now what do you actually have to do? You do not have to keep memorizing these values again. You do not have to keep memorizing everything from here. Make sure what you do is you just remember the final important thing. It is not really important even in your examinations, I am telling you again. Whenever you are actually, remember what is Nessler's reagent? K2HgI4. Okay, and then when you add K2HgI4 to your solution had already our salt, ammonium ions plus KOH, and we have already seen that will result in the liberation of ammonia. So that ammonia will react with our K2HgI4 to give us a brown precipitate which will be nothing but NH2 double bond HgO dot HgI, and that will be brown colored. So once and for all you have to do it. Done? Just go through it as I am taking time to rub the board, and we move on to the next first group of basic radicals. This was our group 0, or sometimes referred to as group 6 as well. Okay, now for the basic radicals of first group, what you do is you add to the original solution, you add dilute HCl. This is what we do. Alright, if we get a white precipitate, the observation, I am in the center writing the observation only as you do it in your practical files. If you get a white precipitate, that white precipitate will indicate the presence of group 1 radicals. What are those? Lead or Ag plus, silver. Okay, it will be either lead plus, or remember that what we do is we try to dissolve it in hot water. We try to dissolve it in hot water. Just now I took up the example of Ag. What was that? Normally now you tell me, if you have Pb2 plus and इसका मतलब Pb2 plus है, and now you can think of the reaction कि क्यों आ रहा होगा. Pb2 plus plus HCl किस चीज़ का precipitate बनेगा? PbCl2. Alright, PbCl2. You know how to balance the compounds. So you have PbCl2, and if it is Ag, what will be the reaction? It will be Ag plus plus HCl giving you AgCl. Okay, that is done. Now what you do is, now that precipitate that you get is either of PbCl2 or of AgCl. You take it in hot water. This will dissolve completely in hot water, and this will be insoluble in hot water. So that would indicate now a demarcation हो गया. What is lead? But I suggest once you get a precipitate in a particular group, perform the confirmatory for each. There's no harm. So, but still you get an indication from here also that PbCl2 is quite soluble in water, whereas AgCl is sparingly soluble. So that is why AgCl would likely be insoluble. And say the salt in that case, if you have to write down the reaction, you know that ions would not exist as it is. You are given a salt. A salt will be a combination of something. So when you jot down the reactions after your analysis is performed, say if supposedly you had lead nitrate plus 2HCl will give you PbCl2 plus 2HNO3, right? Similarly, AgNO3 ले लो. AgNO3, now you can write down the reaction yourself. There's hardly any task in it. So you have AgNO3 plus 2HCl. It will be giving you AgCl plus HNO3. So you can balance it accordingly. Right? So now, in order to perform the confirmatory test for this, what you can do is you can take to the OS add potassium chromate. What is your potassium chromate? K2CrO4. to your original solution add potassium chromate. Okay, now if you're adding potassium chromate, automatically original solution में हमारे पास क्या है, Pb2+. ठीक है, Pb2+ किसके साथ क्या बनाएगा आप बताओ? It will form a molecule with chromate ions. So it will be, say if this is Pb2+, this is CrO4 2-, so it will be PbCrO4. ठीक है, लेड का तो ये वाला प्रेसिपिटेट बनेगा. अब ओरिजिनल सोल्यूशन में हो सकता है सिल्वर है and you have not been able to distinguish based on your water indication. So what you have, you can even get a precipitate for Ag, and Ag will be AgCrO4. No, it will be Ag2CrO4. I'm sorry, because Ag is plus. So you have Ag2CrO4, and if that is the case, the only demarcation between them will be color. Remember, lead chromate ka color will be yellow and silver chromate ka color will be brick red, which is a good distinction between the two. So you can just write down. So if it is yellow, then in that case it is Pb2+ confirmed. If it is brick red, now you can just confirm it because you are getting a proper precipitate for your ion. So that will be Ag+. So in this case what you have is AgCl plus say K2CrO4. That will give you Ag2CrO4 plus 2KCl. Alright. And remember that in all these cases you can even talk about KCl being precipitated out. ये भी तो एक salt है, ये भी एक salt है. ये salt precipitate हो रहा है, ये salt precipitate नहीं हो रहा. Why? Because again you have to talk of the ionic products exceeding your solubility product here. In this case it is like suppressed. Normally the concentrations are not sufficient enough and they are remaining within their range. Got it? So that is why these tests have been designed after a lot of expertise and hard work. So AgCl. Do you want me to write down the reaction for lead as well? Please write it yourself. What it will be? It will be PbCrO4 plus 2 whatever, fine, KCl or just simple KCl. Put down the color also below the precipitate. And normally you show a precipitate with a down arrow. So you should know what is getting precipitated out in which reaction. Okay, and there can also be another test of lead iodide. Lead iodide test is generally for lead only, and you add potassium iodide. Lead iodide test is you again take your original solution. Generally silver is again more expensive in comparison to your lead. So in schools chances are that if you get a precipitate in group 1, it is for lead only. But ideally speaking you should be aware of all the ions which are available, which can be precipitated out. For lead you can either do the potassium chromate test, you will get a yellow precipitate. If you add potassium iodide, then again you get a yellow precipitate only, which confirms your lead. And what will be formed? Now you tell me, if you have Pb2+ plus Ki, it will form Pbi2. Okay, so with this we complete the group 1. Just go through group 1 quickly. In this the basic reagents were dilute HCl. When you've added dilute HCl, if any of the ions of group 1 are present, then you will either think of Pb2+ or Ag+. In order to check initially, the demarcation between the two would be you add hot water, PbCl2 will be soluble, AgCl will not be soluble. Now in order to test it, you will take the original solution and add potassium chromate to it. If you get a yellow precipitate, it is for your lead. If you get a brick red, it is for your silver. Okay, then we move on to group 2 now. Sometimes it may so happen on addition of dilute HCl, you will not get a precipitate initially for lead, and it may so happen that you get a precipitate immediately in your group 2. So then for your group 2 what happens is, for your group 2 we have what all ions did I talk about? Lead, mercury, copper and cadmium. And what are the basic reagents? You add dilute HCl plus H2S gas. Remember this. So in this case generally what happens is, to the original solution you are adding dilute HCl plus H2S. Why am I putting it again is just to look at it that अगर हमने original solution में dilute HCl बनाया तो जितने भी हमारे बेसिक रेडिकल्स हैं उन सबका क्लोराइड बन गया. And why do we add H2S? It means that their chloride could not get precipitated out. So we try to precipitate out their sulfides. So we add H2S. So then in that case, if we get a black precipitate, then it may be indicating either your Pb2 plus or your Hg2 plus or Cu2 plus. Remember that black precipitate will be either because of Pb2 plus, Hg2 plus and Cu2 plus. Now apply your common sense. अगर हमारा Cl2 ही अगर precipitate होना होता तो वो तो it could have precipitated out in group 1 itself. But if it did not precipitate out here, after addition of H2S, what will be this black precipitate due to? It will be due to sulfides of each one of them. So it will be either PbS or HgS or CuS that is there in the black precipitate. So you can write down the chemical reaction yourself. Do it immediately. Put your hands to paper. Although these reactions are very simple, but they will boost your confidence for working out. So it will be either PbS or HgS or CuS. All right. Then if a yellow precipitate is obtained, then you should feel more happy, because yellow precipitate is only for Cd2 plus. But again, this is only an indication. It may be that because of some problem that I talked about, not cleaning or some other reason, do not feel happy the moment you get a yellow coloration or yellow PPT. And there is a difference between coloration and PPT. PPT is some kind of a solid powdered form which is like precipitate which is suspended in your solution. Coloration is simply I take this water and I add a drop of yellow color to it. So it will get colored completely, but it will not give you a precipitate. So please understand that difference also. And I know because everyone is in a hurry to do and complete your salt analysis quickly. So remember that if you get a yellow precipitate, it is Cd2 plus, and what will that yellow precipitate be? CdS, cadmium sulfide. Okay. Remember that cadmium sulfide dissolves in 50% of HNO3. It dissolves in 50% of HNO3, and I'll just give you one basic reaction for that. You can just write down that this yellow precipitate gets dissolved in 50% HNO3, and Cd2CdS plus HNO3 gives you cadmium nitrate, which is soluble, plus for water plus 2NO plus S plus, alright, plus S, right. This is soluble, which makes it soluble in nitric acid. This is 50% nitric acid, which is highly concentrated. Then in the next case, let's talk about now in order to perform some kind of confirmatory test. This is like an indication done, and you know in indicatory you will only get the sulfides precipitating out in this group. Now if you actually add to the original solution, we are moving on to the confirmatory for this, we can add potassium chromate to it, to the original K2CrO4. Now you tell me, if it is lead, what color will you get? You have just done it for group 1. If it is lead, what color? It will be black color, yellow color. Potassium chromate is yellow color. So it will be yellow, and that will be confirming your Pb2 plus confirmed. Okay, then in that case your Pb2 plus will be confirmed. If to the original solution you add NH4OH, I am not writing the reaction for PbCrO4. Do you want me to do that? Write it yourself simultaneously. Okay, then you have in original solution you have NH4OH, that will be a bluish white precipitate, and again you know that bluish white precipitate which is soluble in excess of NH4OH, a bluish white precipitate which is soluble in excess of NH4OH. So you should be adding NH4OH drop wise. Got it? Why? Because if your NH4OH goes in excess, then in again that case you will not get the precipitate. So now in that case you will get a bluish white precipitate which gets dissolved in NH4OH. that is because of ammoniacal solution that gets formed and which is totally blue in color, then that forms a blue colored solution. This would be confirmatory for your Cu2 plus, yes, which is like for Cu2 plus, and you can write down the reaction also for this. You know, if it is bluish white precipitate, what will it be due to? It will be due to CuOH twice. Apply your minds, it will always be the combination of your basic radical with some acidic radical. So it will be your cation combining with OH to form the precipitate, so it will be CuOH twice. So do not ever carry any tricks for noting down the reactions, please remember. You can just do it on your own also. So you have Cu2 plus NH4OH, that will give you CuOH twice, and your copper hydroxide is bluish white in color. Okay, and another better confirmatory for your copper can be, what you do is, to your copper you add dilute acetic acid and potassium ferrocyanide. You take your original solution, add dilute, you add acetic acid to it and potassium ferrocyanide. What is your potassium ferrocyanide? Have you done coordination chemistry now? It will be K4FeCN6. This is like anyways the common name. It is hexacyanoferrate, and then you have potassium hexacyanoferrate. Yeah. So what you have is, you add potassium ferrocyanide to it, then you will get a chocolate red precipitate. Chocolate red precipitate, which will confirm your Cu2 plus. Chocolate red, or chocolate is rather brown. Okay, and try writing down the reaction for this. You can just put the reagents on the left. You have your Cu2 plus. What you have is Cu. First of all, I am telling you that your CuS will be soluble in HNO3 if you are taking the precipitate. You know how to settle down your precipitate? You can use a centrifuge machine. All of you all must be having it in your schools. No? What generally is done is, like, you either take the original solution and potassium dilute acetic acid and potassium ferrocyanide. But just in case if you do not want to use the chemicals again and again, you whatever precipitate you got, वो भी तो chemicals used है ना, तो उसको हम एक centrifuge machine में डालते हैं, which is like you open up the lid, you put your test tube in one side, there is an opposite balance normal test tube kept, and then you close it and then it swirls, quickly moves. जैसे मिक्सी घूमती है ना, so it just quickly moves. The idea of centrifugation is that you must have done it in one of the topics of your 12th standard. The idea of centrifugation is that the precipitate settles down at the bottom. So it just gets settled down like a small powdered form at the bottom. So then it no longer remains suspended in the entire solution, but you get the precipitate at the bottom. And then you can discard the supernatant liquid and you can only have the precipitate, और उस precipitate को आप test कर सकते हो whether that is soluble in your HNO3 or not. So if CuS is again soluble in 50% HNO3, so if it is soluble, it may be because of the copper nitrate which is getting formed. So you can just balance out the reaction. I already have them written with me, so I'm just putting them directly. You have CuS plus 8 HNO3 giving copper nitrate plus 2NO, rest is only balancing of the reactions. But I am telling you what is primarily important for you all is to remember what is getting formed on addition of what. Because it is all a play of the main thing which is getting precipitated or getting dissolved. आपका ion से ध्यान नहीं हटना चाहिए. So we are like right now concentrating on our Cu2 plus, for which we saw that one of the tests can be you take the original solution and add NH4OH to it. When you add NH4OH, क्या बना? कॉपर हाइड्रोक्साइड, उसका कलर ब्लूइश वाइट. 50% HNO3 लेंगे, उसमें ये CuS अगर है हमारे पास तो it will get dissolved. Alright, now if I add excess of NH4OH to this in a solution, because it is kind of an original solution only, so if I take up the original solution in nitric acid, so then in that case, then excess of NH4OH may it will get dissolved completely and it will form a blue colored solution which is due to the complex of ammonium. You will have CuNH3 4 times, NO3 twice plus 4 H2O, and this complex will be blue in color. So this solution is rather blue in color. So this will be added in excess. And then if I add K4FeCN6 to it, or rather than writing, I'll write the reaction directly. So you take your this complex, which is CuNH3 4 times, NO3 whole twice. Say if you add to this may be into plus form. So you have SO4 plus 4 acetic acid. Then in that case you get CuSO4 plus 4 CH3COO NH4. I'll tell you what all things are to be paid attention to here. That will be NH4, and then you have 2 CuSO4 plus, now to this copper sulfate you add potassium ferrocyanide, giving copper ferrocyanide plus 2K2SO4, which is chocolate brown in color. Alright, just note down these reactions quickly. Done? We are still talking about group 2 for all those of you who've lost track after seeing so many reactions. We are talking about group 2. In group 2, sometimes Pb2 plus may not get precipitated as its chloride in group 1, so it may get precipitated here again. Uske confirmatory can be still the same. If you think if it is lead, then what will you do? You will take the original solution, add potassium chromate to it. Yellow precipitate matlab lead. None of the other group 2. If it is not lead, then in that case you can actually move on to test for copper. For copper, we've already stated that copper can get dissolved in HNO3, or the very first thing that you can do is you can take your original solution and add ammonium hydroxide to it. Copper hydroxide will be formed. It will form a bluish white precipitate. Bluish white precipitate का मतलब है we are somewhere here. Some kind of copper, मतलब मैं सिर्फ लिंक बिठा रही हूँ, अभी आपने रिएक्शंस लिखे हैं, तो that can be copper plus ammonium hydroxide will be forming copper hydroxide, which is like your COOH twice bluish white PPT. लेकिन अगर excess में डाल दिया NH4OH तो फिर क्या बन जाएगा? It will form this complex which is blue in color. So the color of the solution will be blue but no PPT. This is like making it blue colored. अच्छा, फिर then what was the point of writing this in continuation with this? हमने क्या करा, अगर मान लो कॉपर सल्फाइड हमारे पास जो प्रेसिपिटेट था उसको सेटल करा लिया यूजिंग सेंट्रीफिकेशन टेक्निक, वी ऐड HNO3 तो वो सोल्यूशन फिर से बन गया. तो हमने सिर्फ दिस कैन ऑल्सो बी डन, या तो आप ओरिजिनल सोल्यूशन लो, उसमें अमोनियम हाइड्रोक्साइड डालो, मान लो ये ओरिजिनल सोल्यूशन था, ठीक है, तो उसमें बिकॉज दिस इज लाइक इजीली सॉल्युबल, सो देन इन दैट केस यू ऐड NH4OH, यू गेट COH ट्वाइस और दिस कॉम्प्लेक्स डायरेक्टली. So that is one thing. अगर आपने original solution नहीं लिया and if you take the precipitate, then to the precipitate add nitric acid, ठीक है, उसको हमने dissolve कर लिया to form copper nitrate and then the same again. The idea is you are reacting your Cu2 plus with NH4OH. So tensions की कोई बात नहीं है. Just in case if you're not able to write down the entire reaction also, I think your teachers should be giving you full credits for your practical examinations, and for entrance anyways you need to understand the basic concepts to tackle problems. So Cu2 plus NH4OH will give you Cu NH3 4 times NO3 twice. Alright, this is a complex which is blue in color, plus you have your 4H2O. Alright, now once this is formed, then in that case you can have even the salt of this reacting with, now what is our now the purpose? Now our purpose is to actually do the test with potassium ferrocyanide. उसके दो तरीके हैं, या तो आप अपना पोटेशियम ओरिजिनल सोल्यूशन लो, उसमें थोड़ा सा एसिटिक एसिड डालो, एसिटिक एसिड जब डालोगे सो यू विल गेट योर वट एवर सॉल्ट कमिंग आउट. सो Cu2 plus is now getting extracted. बात समझ में आ रही है? Even if your Cu was in the complexed form, it will get extracted out using the acetic acid. So your CuSO4 comes out, and whatever ions are associated with your this thing, they will also come out, and then you can have the other gases also that I have not put, but your main focus should be on this. So your copper has come out. Now this copper sulfate reacts with potassium ferrocyanide, all right, to form copper ferrocyanide. So अब याद क्या क्या करना है? You have to remember first thing, black precipitate was due to now CuS. ठीक है? If you are getting a bluish white precipitate, that is due to copper hydroxide, क्योंकि NH4OH डाला. अगर ज़्यादा डाल दिया तो वो precipitate क्यों गायब हो जाएगा? वो CuOH twice बचेगा ही नहीं. It will form that complex. ठीक है? If it is forming the complex with copper, so I mean if complex is getting formed, that complex से आप you can always extract back using acetic acid. So again you are getting your Cu2 plus. You can even write your reactions in terms of Cu2 plus. So then Cu2 plus and Cu2 say in the complex form will with acetic acid your Cu2 plus will get extracted. Now the main reaction for potassium ferrocyanide test is your Cu2 plus interacting with potassium ferrocyanide form copper ferrocyanide. So you have to tell me the test in copper ferrocyanide gives you a chocolate brown precipitate, as I told you. That chocolate brown precipitate is because of copper ferrocyanide, that is Cu2FeCN6, that is in the coordination sphere. Yeah. ठीक है? Any doubts to anyone? So remember that you should be able to explain for each of the substance which is giving the color to your solution. Black color, copper sulfide. Bluish white, copper hydroxide. It is getting dissolved because of the complex formation, that is you have NH3 four times and NO3 twice. Alright, this is your complex which is getting formed. When you have to extract it, you are using acetic acid just for that. And finally you are getting your Cu2 plus. So main reaction for potassium ferrocyanide test is your Cu2 plus reacting with potassium ferrocyanide to form your copper ferrocyanide, which gives you a chocolate brown precipitate. And remember the formula is very simple. But what is your potassium ferrocyanide? K4FeCN6, right? Bolo, what is potassium ferrocyanide? K4FeCN6. So what will be your copper ferrocyanide? Cu2FeCN6. And what is the color of that? Chocolate brown. All right. Next we talk about say mercury ions. Ag2 plus, in Ag2 plus is, let me tell you, insoluble in 50% HNO3. तो फिर क्या करें? If Ag2 plus is insoluble in 50% HNO3, then we use a solution of aqua regia. Heard of it? That is, aqua regia is nothing but 3 parts of HCl and 1 part of HNO3. Please do not forget that. Aqua regia is nothing but you have 3 parts of. If I am now talking about Ag2 plus, still on group 2, this is the third ion that we are discussing. So for Ag2 plus you have HGS to be insoluble in 50% HNO3. So we can instead have Ag plus getting dissolved in aqua regia, and remember that your aqua regia is an important reagent, which is nothing but say 3 parts of HCl with 1 part of HNO3. So reactions maybe you will maintain this ratio. If you are writing down the reaction, if this is 3 HCl, this will be 1 HNO3. If this is 6 HCl, this will become 2 HNO3 and so on. So in this case what happens, we dissolve the black precipitate in aqua regia and add 2 drops of SnCl2. So we dissolve the PPT in aqua regia and add say about 2 drops of SnCl2. What we get is, we get a white precipitate which turns grey. We get a white precipitate that turns grey. This will confirm your Ag2 plus. This confirms Ag2 plus, and here in this case the reaction can be, what was your initial black precipitate due to? HGS. I am writing down the balanced reaction directly. 2 HGS plus, अगर 2 HNO3 है तो HCl कितना होगा? 6 HCl. that will be giving us the precipitate will be mainly due to 2HgCl2. Alright, that will be due to HgCl2 plus rest will just be gases, 2NO, that will be expelled, plus 4 water plus 3 sulfur. So in this case what we have is the sulfide gets dissolved in your aqua regia, but the moment you add SnCl2 तो आपने किस चीज़ की concentration बढ़ा दी? Cl माइनस की. तो Cl माइनस की वजह से अब क्या इसके अंदर precipitate होगा? So you can even write SnCl2 here. 2 drops तो add करी ही है ना, तो chemically clear हो जाएगा. 2 drops of SnCl2 were also added, which increased the concentration of our Cl minus, because of which our HgCl2 got precipitated. Why? Because now you're making the ionic product exceed the solubility product. एक ion का भी concentration बढ़ा दोगे तो the balance gets shifted. Okay. And again, why does it turn grey? It is like you have your HgCl2 reacting with your SnCl2 finally to form SnCl4 plus Hg2Cl2, which will be white in color, and this Hg2Cl2 on standing with SnCl2 forms SnCl4 plus 2Hg, which is grey. Alright, now look into it carefully. We have dissolved our sulfide in our HNO3 along with SnCl2 to the solution. Our HgCl2 gets precipitated to a certain extent and get precipitated further on reaction with SnCl2. When it reacts with SnCl2, it forms SnCl4 plus Hg2Cl2. You can balance the reaction. It forms Hg2Cl2. So the white precipitate is mainly not because of the HgCl2, it is mainly because of Hg2Cl2. And on standing, what happens? Mercury gets extracted from it. So on standing, Hg2Cl2 reacts with SnCl2 to form Hg plus SnCl4 again. So this is like one way of extracting your mercury also. Say supposedly if you have to do research into some years from now, you can always think of extracting it from here. Now coming back to these mercury, let me just check if any other test that I'm missing on. No, for mercury we can just sum up with this to have a basic idea of how the confirmatory tests are performed. Now you tell me, initial color was black agar mercury present tha because of HgS. Alright, then if HgS, you try to dissolve it first in nitric acid mein 50% nitric acid mein it is not soluble. So what are you using for mercury? Aqua regia. What is aqua regia? 3:1 of HCl is to nitric acid. ठीक है, तो इस केस में naturally you are making the chloride which is probably soluble at present. The moment you add stannous chloride to it, SnCl2 उसके अंदर add करोगे तो हमें क्या मिलेगा? Hg2Cl2. This is what color? White in color. फिर अगर on standing when it reacts with SnCl2 even further, then the mercury gets extracted, it forms Hg plus SnCl4 and this Hg will be grey in color. So now you have an understanding as to why the white color is changing to grey. Okay, then we talk about the last ion, which is cadmium 2 plus. So till now what all ions have we discussed in group 2? We have discussed our lead, which if at all not precipitated in group 1 may be precipitated in group 2. Then the next that we discussed was copper, which will form a black precipitate, and then we can have a variety of reactions by adding ammonium hydroxide, or we can add to the original solution potassium ferrocyanide, and we know that the precipitate of copper will be soluble in 50% HNO3. The third that we just discussed was your Hg. And in Hg, we have seen that it will be soluble in aqua regia, and the confirmatory test that we saw was to add SnCl2 to it. Again, mercury is something that is generally avoided in school, so one more ion gets cut. Generally avoided. In some of the schools it may also be given. Then what we have is Cd2 plus. Now for Cd2 plus we have to the original solution you add dilute acetic acid to the original solution, add dilute acetic acid, and then add H2S gas, pass H2S gas through it. Again you get a yellow precipitate which conforms your, cadmium. You can think of the precipitate which gets formed here, that will be your CDS only. Okay, and there can be some more reactions that I can add to it, is that if you have, say, your original solution of cadmium, you can even add NaOH to it. So what will get formed? Cadmium hydroxide. Cadmium hydroxide will be white in color. It will be formed along with NaNO3. This will be white in color. ठीक है, इसके अंदर भी you can add potassium ferrocyanide, then further on, so then CdOH twice, or say this is one test, take another test separately, CdNO3 whole twice plus what is your K4FeCN6, potassium ferrocyanide, and then you get cadmium ferrocyanide, which is again white in color, Cd2FeCN6 plus 4 KNO3. Okay, and done with that. Okay, so for cadmium these are another two tests, both of which precipitates are like white. You can also get a cadmium ferrocyanide, so potassium ferrocyanide will give you a white color. What was the color of the previous ferrocyanide that we did? Forgotten? Chocolate brown. How can you forget it? Go through group 2 quickly. Now with this we complete. See, remember that for cadmium sulfide as it is, it was like a separate entity, because for PBS, CUS and HGS you were getting a black precipitate as the indication. For cadmium sulfide I told you what is the indication, that was yellow color. Yellow precipitate. Now for the confirmatory, for cadmium again we can perform the same test by adding acetic acid and H2S to make sure that cadmium was there. If you are getting a yellow precipitate, that is because of cadmium sulfide only. अगर उसके अंदर या तो ओरिजिनल सोल्यूशन लो, NaOH डाल रहे हो, वाइट प्रेसिपिटेट आ रहा है, तो देन अगेन इट मे बी cadmium, बट द बेस्ट टेस्ट इज H2S वाला, because that confirms your CDS giving you a yellow color. Because white तो सारे ही precipitates, majority of the precipitates that you're getting are white. So I rely more on the H2S test than the other tests. Then the last one is like you can even add potassium ferrocyanide. This will again give you a white precipitate. Those are like time pass tests that you can do once you are confirmed with CD. Okay, then you can spend as much time because you are through. But rather I ask you to concentrate on the writing part also, because that will fetch you marks as well. Done with it? Then writing extra tests only gives an impression, a good impression on to your examiner. External and internal both. Okay, so in group 2, what all ions? Tell me again. Group 2, you have lead, Cu2 plus, Ag2 plus and Cd2 plus. Now let's move on to group 3 then. In group 3 we have aluminium, ferrous and ferric. We're discussing in group 3. So what we have, the main experiment is that to your original solution you add NH4Cl. I have already explained the method of adding NH4Cl, and you add NH4OH. Alright, and here a most common viva question, more than the you get questions based on it in entrance as well, but the external examiner's favorite question, explain what is the common ion operating here, or what is common ion effect, is also one of the most important questions. Remember that your NH4OH is a weak base. Weak base का मतलब है it will be incompletely dissociated, so it will be in some kind of an equilibrium. ठीक है, तो NH4OH क्या होगा? It will be NH4 plus plus OH minus. ठीक है, अब now in order to get an ion common with it, I have to make sure that that ion is sufficiently there. तो वो करता क्या है, when we add NH4Cl to it, NH4Cl solid is nothing but it is NH4 plus, it is like a salt, and as I have told you, all salts are strong electrolytes, remember. So agar if it is a salt, it is anyways a strong electrolyte. So here I have NH4 plus plus Cl minus. So what is the ion common? NH4 plus. Now what is the purpose? You know the Le Chatelier's principle. I'll quickly revise it for you. Le Chatelier's principle is the principle according to which your reaction will try to oppose any change that you bring about in it. मतलब अगर आप इसकी कॉन्सेंट्रेशन इंक्रीज करोगे तो रिएक्शन उसको डिक्रीज करने के लिए इस साइड पे आ जाएगा. इफ यू इंक्रीज द कॉन्सेंट्रेशन ऑफ प्रोडक्ट्स देन इट विल शिफ्ट टू द लेफ्ट. If you increase the pressure, it will move to the side which has lesser number of gaseous molecules. क्योंकि pressure अगर आप बढ़ा रहे हो, then it will try to reduce it. और कैसे reduce करेगा? जहाँ पे भी gaseous molecules कम है उस side पे जाके, क्योंकि gas का ही pressure ज़्यादा होता है. Pressure is mainly due to the gaseous molecules. So, and similarly for the temperature, I am not going into the details of Le Chatelier's principle. Le Chatelier's principle के according, whatever change you are bringing about in your reaction, what is original solution? I'll just explain that question also. But according to Le Chatelier's principle, in Le Chatelier's principle, what do we have? Whatever change you are trying to bring about in the reaction will try to oppose it. But it just wants to balance it out. If you are being partial to this, it will be partial to this. So, if you're increasing this, it will shift to the right. If you're increasing the concentration of the products, it will shift to the left. ठीक है. अब इस केस में normally what we want is it will be some kind of a precipitate which will be formed for OH minus. ठीक है. Are you all getting the point? In this case, whatever precipitate will be formed of the ions, what are the ions that we are generally going to talk about? Al3 plus, Fe2 plus, or we are going to talk about Fe3 plus. ठीक है. Now in this case, whenever we have Al3 plus, Fe2 plus, Fe3 plus, the main precipitate will be of the hydroxide ion only. Now, in order to have sufficient amount of OH minus, जिससे हमारा solubility product सिर्फ हल्का सा exceed हो, we want the ionic product to exceed the solubility product for the precipitate to be formed. So if I want that, I would want this OH minus ion concentration to be just sufficient for these three ions to be precipitated, ताकि group 4, 5, 6 वाले पहले precipitate ना हो. तो उसके लिए I use a controlling factor, that is I introduce a common ion. इस common ion की वजह से ज़्यादा OH minus ions नहीं produce होते, उतना sufficient amount is produced which is like necessary to precipitate group 3. Clear with that? So in that case, I actually add NH4 plus, which shifts my equilibrium to the left hand side and reduces the concentration of OH minus to some extent. What is it? In other words, common ion effect is the one in which a common ion is added which suppresses the ionization of the weak electrolyte. इसका क्या मतलब है? Weak electrolyte कौन सा? ये. इसका ionization मतलब ions form होना. ठीक है. इसको suppression of ionization means I am shifting to the left. So what will suppress the ionization of the weak electrolyte? Addition of the common ion. So what is your common ion effect? Common ion effect is the addition of a common ion addition of an ion which is in common with the weak electrolyte such that it suppresses the ionization of the weak electrolyte. You can look for a better language in the books. Got understood the meaning of the common ion? Common ion effect is nothing but addition of some ion which is in common with the weak electrolyte which suppresses the ionization of the weak electrolyte. So because of, and what is the purpose of doing it here? The purpose of doing common ion effect here is that we want the OH minus ion concentration to be controlled so that only group 3 ions are precipitated. Now let's come back onto it. Now in this case, first of all, let me tell you, if your ion was colored, then in that case if it could be either Fe2 plus or Fe3 plus. और अगर वो colored नहीं है और फिर precipitate आ रहा है तो ये क्या होगा? Al3 plus. These are like general things. You do not have to think of Fe2 plus. White salt है फिर आप आ रहे हो Fe2 plus report करने. That's like a little weird because many of you do it. So what happens is in this case you add NH4Cl and NH4OH. So if you get a white gelatinous precipitate, white gelatinous precipitate, then in that case it indicates your Al3 plus. Okay, if you get a dirty green precipitate, dirty green, green indicates your Fe2 plus. Right at the beginning is this is what we did. And if you get a reddish brown, if you get a reddish brown precipitate, then in that case you have your Fe3 plus. Okay, Fe3 plus. Then now say in this case, what is the white gelatinous precipitate due to? You have AlCl3, you are adding NH4OH, general reaction तो ऐसे ही लिखोगे, or you are adding OH minus ions to it. So the precipitate is because of AlOH thrice का precipitate plus you have 3NH4Cl. Simple reaction, you all could have written that. Because in all these cases anyways, what is getting precipitated? Tell me, if this, in this case you are getting AlOH thrice, in this case you will get FeOH twice, in this case you will get FeOH thrice. Simple. You just have to jot down your reactions in the correct fashion, and nobody can put you wrong if you are actually writing the precipitate correctly. So make sure that you do it, and rest is just to go through. So you have your, and let me tell you what is the difference between a white precipitate. What is the difference between, I have already discussed this question. First of all, let me just come to the doubts for about half a minute's time. What is the original solution? Original solution is like, सबसे पहले आप क्या लोगे? अपना salt, ठीक है? उसमें आप सबसे पहले solution बनाने के लिए what will you add? Water. If it gets dissolved in water, wonderful, original solution prepared. This original solution is what we are referring to as OS and OS again and again. Okay, it may be required, you can stock it a little extra, but do not waste chemicals unnecessarily. I am a chemistry teacher, I do not like it. Then the next thing is, if it is not getting dissolved in water, there may be some salts, जैसे AgCl है, हम कह रहे हैं वो dissolve ही नहीं हो रहा. Ag plus हमारा basic radical हो गया, Cl minus हमारा acidic radical, so वो dissolve नहीं होगा. So then you can try first dilute HCl. What you can try? Dilute HCl. That's a dilute acid. Zara sa dilute HCl डालो. You can either add it to your aqueous solution or you can just add it to the salt. If it gets dissolved, wonderful. We do not prefer acids in this case because sometimes chlorides may be precipitated out. क्योंकि dilute HCl मतलब you're adding an ion. चलो अगर नहीं हो रहा तभी the best sometimes if at all you have absence of nitrate, then in that case you can even add nitric acid. We have discussed the solubility in nitric acid also. Then we have seen that in certain cases your precipitates are soluble in nitric acid, in certain cases they are not soluble. अगर वो nitric में भी soluble नहीं है तो फिर क्या करोगे उसका? Aqua regia बनाओगे. And aqua regia is a ratio of 3 HCl is to 1 HNO3. So these are the ways of creating pure solutions. Alright. Generally, original solution is referred to as the solution of the salt with water. And if it is not getting dissolved, that's a problem. Please discuss it with your teacher. You need to get a proper solution to move ahead. Because अगर आपका solution dissolve ही नहीं हो रहा, you may get confused between that powdered form and the PPT. आपको यही नहीं पता चलेगा कि ये वैसे का वैसा ही है या कोई नया PPT बना है, क्योंकि अगर dissolve नहीं हुआ, already it's white, and then you're adding say something to it, the reagent, it will again be white, तो आपको पता ही नहीं चलेगा whether that's a precipitate. So a clear solution is kind of mandatory. Okay, next question. Why Fe belongs to group 3? We have just discussed it, that here we have demarcated our groups in accordance with the kind of solubilities and the ionic products they are actually demarcating, and we have segregated their properties based on their reagents also. So that is how the demarcation has been done. This was like question put by 2-3 students before also. Then we move on to aluminium. Aluminium का confirmatory test जो होता है ना, that is a blue lake test. It gives you, and what is the difference? Abhi tak I was just writing white PPT. What is this white gelatinous precipitate? You've seen a jelly? So it is like kind of a jelly which is white in color. It forms a gel which gets suspended. So you will, it is like, it comes wonderfully well if you get aluminium, and it gives you a lot of happiness when you see that white gelatinous precipitate. So something that boosts you and puts you in high spirits. Then you have ALOH thrice. Okay, now the blue lake test is like the confirmatory. I don't know which one do you follow. And blue lake test can be performed as the confirmatory for aluminium, and in that you have the aluminium salt plus a few drops of litmus solution, litmus solution, let me tell you, acts as a pigment, plus dilute HCl plus NH4OH. अच्छा, और एंट्रेंस में IIT JEE में 2 years back there was a question based on it that what is your litmus pigment adsorbed on. Adsorb का मतलब पता है ना, just on the surface. So what you have is, you have the aluminium salt, हमने litmus solution को as a pigment add करा है, and then we've added our normal reagents, maybe HCl and NH4OH. What happens, remember all these things are to be added gently, यानी कि यूं करा और काम खत्म. You have to add them gently, sometimes even drop wise. So here in this case, just as you do it for the brown ring test for the acidic radical, one of the acidic radicals. So in this case you have aluminium salt, हमने litmus pigment add करा solution के form में, and then we have dilute HCl और उसमें हमने डाला ammonium hydroxide. Precipitate किसका बनेगा? Aluminium hydroxide का, ठीक है, ALOH thrice का precipitate बनेगा, और जो blue pigment है ना, ये उस precipitate के ऊपर absorb हो जाएगा. So it will look as if it's a blue lake. Got the point? Say if you have your test tube, I am saying it's kind of a gelatinous precipitate which will be like a proper, you know, it will be having a proper zigzag or maybe some kind of a haphazard shape which is suspended very nicely in your test tube. And when you perform this test of litmus solution with litmus solution, then it will give you a brilliant blue lake. So the question in IIT JEE was, what is this litmus pigment adsorbed on? Whether it is adsorbed on aluminium, then there was aluminium hydroxide, then there were 1 or 2 more options, but the correct answer was aluminium hydroxide. So remember that it gets adsorbed onto aluminium hydroxide to give you the blue lake. So that is like the confirmatory test for aluminium. Then for Fe2 plus or Fe3 plus, let me tell you, if it is Fe3 plus, you can check it for Fe3 plus first. In majority of the cases, you know, ferrous immediately gets converted to ferric ions. So Fe2 plus becomes Fe3 plus immediately. So with in group 3, what you can do is you can directly perform the confirmatory test for Fe3 plus. So I'll give you the test for Fe3 plus now. In Fe3 plus, you have FeCl3 plus you add ammonium hydroxide to it, directly to it, and you have the precipitate forming for FeOH thrice. What will be the color of FeOH thrice? Silence? Brown. Look into the colors. Indicatory test तो सबसे पहले याद होना चाहिए. आपने अपना NH4Cl लिया, उसमें सिर्फ NH4OH ही अभी ऐड करा है. White gelatinous precipitate मतलब aluminium. अगर dirty green precipitate तो Fe2 plus. अगर brown precipitate तो then it is Fe3 plus. So now if you have FeOH thrice, then that will be brown in color. So keep writing it also simultaneously so that you remember. Confirmatory would be like you take your FeCl3 and add potassium ferrocyanide to it. So it is like one of the favorite confirmatory reagents. Add potassium ferrocyanide to it. So you will get ferric ferrocyanide. Ferric ferrocyanide is Fe4, FeCN6 plus KCl. And ferric ferrocyanide will be Prussian blue in color. It will be Prussian blue in color. Okay, and then you have your FeCl3 also can also be reacted with potassium, say KCNS, sulfocyanide. So then in that case you have KCNS giving you FeCNS whole thrice plus 3 KCl. This is ferric sulfocyanide. This is ferric sulfocyanide which is brick red in color. The point here to make you write down all these reactions is that you just have to remember See, you have to remember ferrate is like one ion which is in your complex form. So you remember that whenever your ion is your coordination complex or the inner sphere, that's the closed square bracket one, carries a negative charge. In that case, you name your metal atom after with an 8. So it is cuprate, ferrate. So ferrate तो वहाँ use होता है. Now your question probably is to ask the difference between ferrous and ferric. Okay, so Fe2 plus is ferrous, Fe3 plus is ferric. So remember that ferrous goes to ferric always. So what is your Fe2 plus? Ferrous. What is your Fe3 plus? That's ferric. So us going to ick. So remember now for Fe3 plus, the test that I've given you, the very first one is like the indicatory test in which you're getting the basic color as it is, that's brown. Okay. Now it may sometimes so happen that your Fe2 plus gets oxidized to Fe3 plus. So it is always appreciable to confirm this test with your addition of potassium ferrocyanide. If your potassium ferrocyanide is added and if it gives you a Prussian blue color, Prussian blue is also a very peculiar colors. All these colors are like, you get to know more about colors when you perform these tests. So Prussian blue color is of ferric ferrocyanide. Okay. Ferric ferrocyanide in which your main ion is like out attached here. Then and not as a in the inner sphere. Then what we have is FeCl3 plus, another is like you can add KCNS and you will get ferric sulfocyanide which will be brick red in color. So in group 3 we've discussed only two ions basically by and large. What are those? One is aluminium and the other is iron. Okay, and remember that for aluminium there is a clear cut demarcation that it will be a white salt and your iron will either be green in color or it will be like a little say greenish brown in color. So if it is Fe2 plus, then you know it is going to be green, and if it is say greenish brown, then it will be Fe3 plus. Alright, and then depending upon the hydroxide color also you can actually demarcate. If it is green in color, dirty green, then it is Fe2 plus. If it is brown, then it is Fe3 plus, and the confirmatory tests can be done by adding either potassium ferrocyanide or by adding potassium sulfocyanide. So remember the formulae. These basic things are to be remembered. Okay. So I'll ask them once you forget them. What is the formula for Nessler's reagent? K2HgI4. And what about potassium ferrocyanide? K4FeCN6. Potassium sulfocyanide? KCNS. Okay. So now we move on to next group, that is our group 4. Now in group 4 again, I told you if group 3 is not coming in, you just have to add H2S to it. So what you have is in group 4, you had the basic radicals as Zn, zinc, manganese, cobalt, nickel. Please ये तो याद ही रख लो, ये initially ही याद होने चाहिए कि what are you expecting now in group 4? Zinc, manganese, cobalt and nickel. You have zinc, manganese, cobalt and nickel. So now what are you doing now? To the original solution, आपने पहले से क्या ऐड करा हुआ है? NH4Cl solution, and the technique will just be the same. Your NH4Cl solution has to be in such a fashion that your original solution is like completely saturated. Now then you add what to it? NH4OH, followed by you will be adding now H2S gas to it. तो naturally hydroxide इसका मतलब precipitate नहीं बना पाया. That means it could not exceed its solubility product. So in इस case में क्या क्या precipitate होगा? Sulfides again. So again in group 2 and group 4 there is one similarity that you are getting the precipitate mainly due to the sulfides. So in this case you get a white precipitate, then it is indicating your Zn2 plus, Mn2 plus and CO2 plus. So zinc, manganese and cobalt. And इनमें से colored ion हमने किया है, कौन सा है? Manganese. In fact, cobalt is also colored. Now here, you remember that manganese had color of flesh or pink colored, and cobalt I think has some kind of a greenish tinge. If I am not sure, so I will not tell you. So now you have, if it is a buff or a, see if it is white, then it may be manganese, because for all you know, there may be a color disparity. But if it is a buff or a pink colored, then or pale pink, then it will be, Please, in all these cases, I am not writing PPT. I don't know where did I miss it. PPT has been obtained in all, and wherever there was a coloration, I did tell you that it is a coloration, not a PPT. So a buff or a pale pink color, which is soluble in dilute HCl, which is soluble in dilute HCl. So that will be your indication of manganese. What are we left with? Nickel. So in this case, for nickel, what you can actually have is, nickel also will give you in this only. Nickel can also form a part, but then nickel precipitate would be a little green. I haven't noted it down for nickel, so it will be some kind of greenish white precipitate. That will be your Ni2 plus. Okay. Now for the confirmatories, what you can do is, to the original solution you add for zinc first of all. Let me tell you, for zinc also it is a little dirty white precipitate. When you will perform it, you will learn even more, because what comes with experience doesn't come from the bookish language. Original solution, you add just NaOH. Okay. If you get a white precipitate which is soluble in NaOH, add a little of NaOH and then check if this white precipitate is soluble in excess of NaOH. If it is soluble in excess of NaOH, then it means that your Zn2 plus is confirmed. Okay. White, as far as I do remember, it's a little dirty white, so just check it. Okay. And if this white precipitate is insoluble, if this white precipitate is insoluble in excess of NaOH and turns brown, then in that case it confirms your Mn2 plus. Then in that case it confirms your Mn2 plus. In both these, sorry, now here what we have is Mn2 plus. This your Mn2 plus. What was your precipitate, the pale pink or whitish precipitate in Mn due to MnS? So we have the manganese sulfide precipitate. We are adding a little bit of HCl to it to form MnCl2 plus your H2S is liberated out. This MnCl2 can react with your NaOH to form MnOH twice, precisely the precipitate that we are just talking about. And here Zn will react with, similarly ZnCl2 will react with NaOH to form ZnOH twice. These are simple reactions that I think now even you will be in a position to write. You know that the moment you are adding a hydroxide, to hydroxide ही precipitate होगा. So apply your common sense here, that ZnCl2 plus NaOH will give you ZnOH twice, plus you will have NaCl again. Now which of the two precipitates will be soluble in NaOH? That will be ZnOH twice. ZnOH twice will be soluble in excess of NaOH, and your MnOH twice will not be soluble. And you can even add bromine plus water to create 2HBr plus, oh, this is your bromine water. This bromine water when added to your manganese hydroxide precipitate. Remember that bromine water helps in the creation of nascent oxygen. This type of an oxygen, which is like single-handedly staying on its own, is known as a nascent oxygen. And when this nascent oxygen reacts with your MnOH twice, it gives you MnOH twice, which is again pink in color, and this is also kind of a confirmatory test. So you can just remember this reaction. This was asked in the exam once. What is the final formula of the compound formed? So in this case what you have is bromine water is liberating a nascent oxygen is what you have to remember. The combination of bromine plus water gives you a nascent oxygen plus your HBr. That's like a side thing. Then that nascent oxygen actually reacts with your precipitate of manganese hydroxide to form MnOOH twice, which is kind of pink in color. Alright. Then there is a PbO2 test also. In PbO2 test what happens is you add PbO2 test, you have say manganese sulfide, you have in PbO2 test say you have MnS plus 2HNO3. This implies that this is kind of soluble in nitric acid. The sulfide is soluble in nitric acid, so it forms your MnNO3 whole twice plus H2S. So manganese sulfide reacts with nitric acid to form the nitrate, which are generally we've seen majority of the sulfides were soluble in nitric acid except one, that was the Hg case. ठीक है, तो इस केस में this manganese nitrate can then, this is the PbO2 test. Some of the tests which are commonly known. Otherwise, I tell you there are a large number of tests that you can actually refer to. The best book, you are not in a position to devote extra time, but still if at all, the ones who have been very regular in studies and can devote some extra time can refer to this book by Vogel. Because whatever tests I have picked up are generally from this book only. So you have MnS plus 2HNO3 giving MnNO3 whole twice. This is for the PbO2 test. So here you have 2 MnNO3 whole twice plus 5 PbO2 plus 6 HNO3. Alright, so it's a combination of HNO3 and PbO2. That's giving you 2 HMNO4 pink in color, which is pink in color, plus 5 PbNO3 whole twice plus water. Remember the final coloration, जिसका जो भी final color है. In this case of PbO2, you get again a final pink color here, which is because of HMNO4. That you can remember anyways. Then for cobalt, next we move on to for cobalt, and note down for cobalt, it is like very important you have dissolve your precipitate in aqua regia. Note down the procedure. Dissolve your precipitate in aqua regia. Okay, what was the precipitate that you got? What was the precipitate? For cobalt sulfide, because you had added H2S to it. So you have dissolved your precipitate in aqua regia. What is your aqua regia now? All of you all tell me. Be louder so that you wake up. 3:1 HCl and HNO3. So you dissolve your PPT in aqua regia, and what generally you do it, you evaporate it to dryness. इतना तो time ही नहीं होता to evaporate it to dryness. Just gently heat it and evaporate it a little, and evaporate it to dryness, and add 1 say milliliter, generally a little of distilled water, because you're doing everything like without any measures. You add 1 milliliter distilled water, and now इसको हम दो parts में divide कर देते हैं. To the first part, you add 1 milliliter of an alcohol, which is amyl alcohol. You add 1 milliliter plus 100 grams of solid ammonium sulfocyanide and mix it. ठीक है? And to the other, you add 5 drops. To the other, add 5 drops of DMG reagent. 5 drops of DMG you add 5 drops of DMG reagent. Okay, now this test is mainly for cobalt and this test is mainly for nickel. Now when you add amyl alcohol and solid ammonium sulfur cyanide to it, in this case you get a blue color. In this case you get a blue color which confirms your cobalt. And you can actually think of that blue color maybe because of the formation of cobalt sulfur cyanide. So do it yourself. Now just write down the final product so that we just discuss the other things also quickly. I repeat, what have we done now? We have taken care of zinc and manganese once. Zinc and manganese have been taken care of. In zinc and manganese, what are we are on group 4 presently, and we have already seen that we can get two kinds of precipitate in this case. Just in case if you get a white precipitate, then it may be indicating 3 ions which are namely your zinc, manganese or cobalt. If it is a buff or pale pink white, then it is your manganese for sure, and nickel may be some kind of a greenish precipitate. Now we are on to the confirmatory tests for that. For the confirmatory, what did we take? We took the original solution and added NaOH to it. If we add NaOH to it and we still get a dirty white precipitate, it is your zinc hydroxide. If it is not a dirty white precipitate which is soluble in excess, if it is insoluble in NaOH, then it is for sure your manganese. Alright, and then I declared two more tests to you. One was the bromine water test in which you get MnOOH twice, and there was another PbO2 test in which you get HMnO4 which is pink in color. So this again confirms your manganese. After manganese, we've just moved on to the other two ions of group 4. What are those? Cobalt and nickel. Now for the cobalt and nickel, what have we done? We've taken the precipitate and dissolved it in aqua regia. In aqua regia, then we've added a little water to it. That's like understood. So you take it in aqua regia, that's one same thing. Now divide it into two parts. उसी precipitate को use करेंगे because we have a confusion between your cobalt and nickel, both of which are colored. So in this case of cobalt, we add a little amyl alcohol to make it a little in order to neutralize whatever sulfide you had got initially, and then we add 100 grams of don't refer to this, we add some solid ammonium sulfur cyanide, because if you 100 grams is just too much. So you add a little of solid ammonium sulfur cyanide. When you add sulfur cyanide, you know what kind of a precipitate will now be formed? Cobalt sulfur cyanide, which will be blue in color. So it confirms your cobalt to be there. And just in case when you add nickel and DMG to it, to the same solution, if at all you add DMG reagent, what is your DMG reagent? It is dimethyl glyoxime. This is one of the important tests which is asked again and again in the examination. So if it gives you a pink color, pink PPT, not color, pink PPT, colored PPT, then in that case it confirms your Ni2 plus. For cobalt, you know that cobalt sulfur cyanide, which will be a blue color in the alcohol layer. Remember that blue color will be there. It is not a precipitate, but it's a blue color which will be in the alcohol layer of the solution. And then for nickel, nickel is like an important test because here you get a kind of a ring structure formed, which is very important. Say supposedly you had nickel chloride as the salt, so you have your NiCl2 plus you added ammonium hydroxide to it, because that is what you are taking. You have taken your precipitate basically. So ammonium hydroxide plus your DMG reagent, which is nothing but CH2CNOH, and this is again CH2CNOH, alright, and that gives you your nickel DMG complex, which is pink in color. So this complex is kind of the examiner's favorite. You get a nickel DMG complex which is pink in color, and you will find your DMG reagent kept on the side shelf in your labs if you go. So what have we done? We've taken nickel chloride, we've added ammonium hydroxide to it, and this is our DMG. And when we add it, what we get is some kind of a complex which is like nickel is in the central atom. Then you have NCCH3, you have NCCH3, here you have OH attached to it, here you have O, and then you have similarly NCCH3, here you have an OH attached to it, and here you have an O, alright, and this is CCH3. C is attached here, C is attached here. So this is the nickel DMG complex, which is bright, sometimes dark. So sometimes in some of the books you will find even a bright red color mentioned for it, is like dark, very bright pink in color. So this is like a very peculiar test which is very commonly very fascinating. So that is why I asked probably in the examination also way too much. Remember that what have we done for the cobalt and nickel confirmatory test? We have taken our precipitate. The precipitate will be essentially of COS and NIS, and we have dissolved that precipitate in aqua regia. So after mercury, अब aqua regia की बारी किस में आई? Cobalt और nickel में. So remember that we added aqua regia to COS and NIS, and probably it got dissolved. Whatever was there, you will have only one basic radical. So once that gets dissolved, now we have added DMG to it simply for the nickel if it gives a pink color. That pink color is because of the nickel DMG complex. So in many of the books you will find it as written as Ni-DMG. Khatam. You should just know that that's a complex formed with DMG. What is DMG? Dimethyl glyoxime. I have already given the formula for that, CH3CNOH, and you have CH2CNOH, and then you just close it. So some kind of formula is that. And then when it forms a complex, that's pink in color. Once that is done, after that we have another reaction to be taken care of, that is for the confirmatory of cobalt. And in cobalt, what did we do? We added amyl alcohol, and we added sulfur cyanide of a salt. Some salt sulfur cyanide, that is SCN. And what did we get? We get cobalt sulfur cyanide, which is blue in color. And where is that blue color suspended? It is suspended in the alcohol of that solution. Done with it? Then we move on to the next quickly. We have now say the group radicals of group 5. So now just to wake you all up, we have done 4 groups till now. Group 0 had ammonium ions. Group 1 had lead, silver. Very good. Thankfully you remember silver. It did not get lost. Then in group 2 you have lead, mercury, copper, cadmium. Very good. And then in group 3 you have aluminium, ferrous, ferric. Okay, no ferrate. Then in group 4 you have zinc, manganese, cobalt, nickel. याद रहेगा, you can club zinc and manganese together, cobalt and nickel together, क्योंकि उनके tests भी एक जैसे हैं. In zinc and cobalt you had added NaOH to get a buff colored or dirty white colored, and for cobalt and nickel you had added DMG and you had added aqua regia first of all, and then DMG for nickel and SCN for cobalt. ठीक है, तो ये याद रहेगा. Now let's move on to the 5th group. This is like kind of a easy group where you have calcium, barium and strontium. तीनों के तीनों white colored होते हैं, तो इसीलिए बहुत confusion भी होता है, but the chances of getting it is like very often you get it. And what you have is calcium, strontium and barium. Okay, you have calcium, strontium, barium. Now in this case, our basic reagents were what? You take the original solution. To the original solution, group 3 वाले reagents तो डलेंगे ही डलेंगे. That was your NH4Cl plus you have your NH4OH, and then you add your ammonium carbonate. Why do we have to now add ammonium carbonate to this? Because it clearly indicates your hydroxide was not getting precipitated. Sulfide may not be really helpful. So now we are adding carbonate. So what will get precipitated in this case to give you a white precipitate? It will be carbonate. If you are getting a white precipitate, it can indicate any of the three. It can be any of the three: calcium, strontium, barium indicated. Because it, and what will be the precipitate? You can write down the reaction on your own. The main reaction goes of Ca2 plus NH4 twice CO3. ठीक है, मेन रिएक्शन तो आपका कार्बोनेट के साथ ही है. तो दिस वाइट प्रेसिपिटेट मे बी ड्यू टू, आप मुझे बताओ, इट विल बी आइदर CaCO3 और SrCO3 or it may be BaCO3. So it can be either of the three precipitates which we are getting here. Then for this, इसके अंदर it's kind of an interesting test. What you do is dissolve this white precipitate. Now we move on to the confirmatory. Dissolve the white precipitate obtained in small amounts of dilute acid. Dilute acetic acid. Dissolve the white precipitate in small amounts of acetic acid. ठीक है, तो मे बी इट इज एज गुड एज गेटिंग डिजॉल्व इजिली इन एसिटिक एसिड. एसिटिक एसिड में जब उसको डिजॉल्व करा, इसके अब 3 पार्ट्स बना लो. ठीक है, 3 पार्ट्स बनाए, 1 2 3, क्योंकि टेस्ट किसका करना है? 3 सॉल्ट्स का करना है. एक में ऐड करो पोटेशियम क्रोमेट K2CrO4. नेक्स्ट में ऐड करो कैल्शियम सल्फेट, और थर्ड में ऐड करो अमोनियम ऑक्सलेट. सो दैट इज NH4 whole twice, oxalate is your C2O4. okay, simple. सबसे पहले क्या ऐड करेंगे हम? and remember that this order has to be followed. okay, this order has to be followed. If you have barium, because barium will give you a white precipitate with all, but the others will not give it for this. So इसीलिए I am telling you to follow this order. सबसे पहले टेस्ट करेंगे हम बेरियम का. okay, so in this case what have we done? We took the precipitate. precipitate क्या था? कार्बोनेट. ठीक है, और जनरली OS में भी ऐड करने से you get it. but what you do is, इससे ये पता चलता है that your white precipitate is soluble in acetic acid. उसमें हमने डाला पोटेशियम क्रोमेट, we'll get a yellow precipitate. if it is yellow, then that means your Ba2 plus is confirmed. ठीक है. If it is now for calcium sulfate, if it is thin white मतलब you take a little bit of color and add a lot of water. If it is a white colored precipitate, because you will see varieties of whites when you perform the analysis, if you do it with known salts. ठीक है, if you have thin white precipitate, then it is your strontium. And if you have here for oxalate a white precipitate, then in that case it will be your calcium. So remember it in the order of barium, strontium, calcium only. This is kind of the easiest that you can actually do. Then I will talk about the flame test also for all 3 of them. I repeat, group 5, one of the easiest, but simultaneously has to be done carefully. Why? Because we are dealing with the white precipitates here, and the salt is also white in color. In this case, what we basically have is, we have our original solution. Now we have in this case basically we are talking about barium, strontium, calcium. सबसे पहले हमने एक additional reagent इसमें जो add करा है in addition to group 3 reagents is ammonium carbonate. Remember that if ammonium carbonate is added, whatever precipitate you are getting will be your carbonate which is getting precipitated out. So you have barium, strontium, barium, strontium, calcium का carbonate which will get precipitated in the white form. Now how to distinguish? अगर precipitate निकालना है तो it's easy, centrifuge machine में लगाओ, 1 second चलाओ, test tube बाहर निकालो, the precipitate will be at the bottom, throw the supernatant liquid, dissolve that precipitate in your acetic acid. In acetic acid, what was aqua regia used for? Ag and cobalt and nickel. Good. Okay, so now we dissolve this. Anyways, we dissolve the carbonates in your acetic acid. Once we dissolve them in acetic acid, we now divide them into 3 parts. उस solution के हमने 3 parts कर लिए. पहले part में सबसे पहले डालेंगे potassium chromate. Yellow precipitate confirms barium. खत्म. Then to the next part you will add calcium sulfate. Calcium sulfate means if it is already calcium, तो फायदा ही नहीं है ना. कैल्शियम सल्फेट तो आपके पास ऑलरेडी है, वो वाइट प्रेसिपिटेट देगा ही देगा. तो पहले हम किसको टेस्ट कर रहे हैं? स्ट्रॉन्शियम को. सो व्हेन वी ऐड कैल्शियम सल्फेट इट विल बी योर स्ट्रॉन्शियम. इफ यू गेटिंग अ प्रेसिपिटेट नाउ दैट विल बी बिकॉज ऑफ स्ट्रॉन्शियम सल्फेट. ठीक है. और अगर यहाँ पे येलो कलर है, दैट कलर इज ड्यू टू BaCrO4. हियर द कलर इज बिकॉज ऑफ SrSO4. and when you add ammonium oxalate, that oxalate will give you white precipitate only for calcium. ठीक है. तो here you will definitely get your CaC2O4 and that will be your white in color, that confirms your calcium. Now let's take up the doubts here. What is buff color? Buff color is like brownish और white को mix कर दोगे ना, तो you will get some kind of a buff color. Am I right? So you have the brown color and you mix it with a little bit of more of white, such that white is also not attained and brown also loses its identity. वो होता है buff color. और जब experiment करोगे तो then consult it with your teacher also, what color, and you start asking questions. Ma'am, CaSO4 is to be taken in which form? It is not to be taken, it is to be added. ठीक है. तो CaSO4 will be added to the solution. You can actually add the solution of calcium sulfate which is available in the lab. Okay, so you can add calcium sulfate solution. In all these cases, let me tell you, till it is mentioned exclusively as solid, तब तक solid नहीं add करना. अभी तक हमने solid mainly किसका add करा है? NH4Cl. NH4Cl solid, and you will not enjoy it probably these days because it's cold. Whenever you add NH4Cl and shake it, the test tube becomes immediately cool. Why? Because it is an endothermic reaction. जो एक्सो होगा वो हीट लिबरेट करेगा, जो एंडो होगा वो हीट अब्सॉर्ब करेगा, वो ठंडा हो जाएगा. So those things like are not related to this. Anyways, can you please make the table for all color of precipitates for all groups? In the end, yes, when I'll discuss. Anyways, I have the habit of repeating too much. So anyways, we'll discuss it in the end once again before we wind up. We have little less time left. So yes, let's talk about, this is done, group 5. Thorough with group 5 also. Revise till group 5 as I am rubbing the board. So I am giving you about 1 minute's time. Please try and write down the reactions for each of the tests that are there. And just in case if you have any confusions, you can always mail and ask. Or you can ask the coordinators here to just to confirm. What is the formula of aluminon? It is like mainly a salt of aluminium generally. So if it is an probably you're asking about sodium meta-aluminate, that is NaAlO2. So that is like probably aluminon. Otherwise I do not think I did talk of any aluminon. No. So just take it off. Okay. Then all right. I was talking about the flame tests. Okay. Now when I talk about the flame test, I'm still on the group 5. बिकॉज ग्रुप 5 में ना कई बार कन्फ्यूजन हो जाती है. कैल्शियम सल्फेट का अगर ऐड करने पर वाइट प्रेसिपिटेट आ रहा है, तो इवन इफ यू हैव कैल्शियम इन योर सॉल्ट दैट विल आल्सो गिव अ वाइट प्रेसिपिटेट. देन उसके बाद स्ट्रॉन्शियम और कैल्शियम में कन्फ्यूजन हो सकता है थोड़ा सा, इन ऑर्डर टू अवॉइड दैट डिस्क्रिपेंसी. एंड बेरियम ऑल्सो विल गिव यू अ वाइट प्रेसिपिटेट ऑफ बेरियम सल्फेट, बिकॉज बेरियम प्लस योर कैल्शियम सल्फेट Ba2 plus CaSO4 will again give you BaSO4 plus Ca2 plus. So that in order to just avoid that confusion, we can add do the flame test. And in flame test, what you do is you make a paste of the salt with a few drops of concentrated HCl. You make a paste of the salt and add a few drops of concentrated HCl. Ammonium chromate Basically, whenever you take an ammonium salt, they're generally whitish in color and they're like similar to white color. What is more important is the color which is obtained after you react them with your iron. Okay, so ammonium chromate, ammonium dichromate, in fact you've put NH4 twice Cr2O7, which is essentially whitish in color only. And whenever you make this dichromate interact with your potassium or with your barium or something, then in that case it is whitish yellow in color rather, so that when it actually reacts with something of the sort of like barium or strontium, or you have potassium dichromate even added for your chromyl chloride test. Alright, there in itself you add a little yellow and that results in an orangish red precipitate. So the color change basically whenever you take up a Cr2O7 is due to you add Cr2O7 2 minus, and say if you are taking it in acidic conditions, it gets converted to either Cr3 plus, or if you are doing a direct reaction of exchange, then it can actually give you any of the precipitates which can rather gets formed. So your K2Cr2O7 you know is actually yellow in color, your ammonium salts are generally white in color, this will be whitish yellow in color, so somewhere in between. That is I am talking about from the etymology of the basic chemicals that we deal with. Okay, so now flame test पे वापस आते हैं because that is like an easy one to do. Paste लो salt का, उसके अंदर you add a few drops of concentrated HCl. Add a few drops of concentrated HCl, and what you do is you heat a platinum wire in non-luminous flame. Heat a platinum wire in non-luminous flame. I'm sure it must be given in your notes as well, I don't know. Non-luminous flame, and hold it in the flame. आपने क्या करना है, एक platinum wire है, it will be available in your lab. Take the platinum wire, non-luminous flame मतलब जो बहुत ज़्यादा luminous नहीं है. Luminous क्या होता है, जो बहुत ज़्यादा light throw कर रहा है, which is like normally blue in color, perfect for the Bunsen burner. लो उसको गर्म करो, फिर उस पेस्ट में लगाओगे तो फिर वो चिपक जाएगा पेस्ट उसको, and then you take it to the flame. Now note the color. Immediately that blue color flame will give you different colors, and those colors will be kind of confirmatory. अगर apple green color है, if you have an apple green color, then in that case your barium is confirmed. If you have a crimson red color, crimson red is the proper red, okay, the proper red होता है ना. Brick red is a little darker, I stated that before. If you get a crimson red color, then your strontium. I think I did that in the beginning also. And if you have a brick red color, क्या बच गया? Calcium. So this is also kind of a demarcation for at least your barium will be absolutely known. Crimson red और उसमें फिर भी confusion रहेगा, then you can actually go ahead with your chemical reactions. Fine. Now moving on to the sixth group of the radical. Now in the sixth group we generally talk about a white precipitate being obtained on adding excess of ammonium hydroxide and ammonium hydrogen phosphate. Remember group 6 तो अलग से याद रख सकते हो. What is that? You add ammonium hydroxide and ammonium hydrogen phosphate. Okay, so now in group 6 we are left only with one ion, Mg2 plus. This is like very well known, even if it is not given to any of the students. It is like you keep on asking कुछ आया. I don't know if you've been practicing it in lab quite often. तो किसी का 5th तक नहीं आया तो everyone gives you will give your friend a little bit of consolation by saying it may be magnesium. So for that magnesium is very well known, and it is easy to do it also. You take the original solution of your salt and you add excess of ammonium hydroxide to it. You add excess of ammonium hydroxide to it. When you add excess of ammonium hydroxide, you're making sure that there are sufficient number of OH minus ions, and you add ammonium hydrogen phosphate. Ammonium hydrogen phosphate. A white precipitate will be obtained which will confirm your Mg2 plus. Which will confirm. How to learn the flame color? नॉर्मल फ्लेम कलर इज, आपको पता है, ब्लू. अब इसमें कुछ लर्न करने के लिए है नहीं है, because blue color is like something that you actually get from observations and your own experience of doing it again and again. So it is like an observation. तो barium is going to give you a green color. तो आपको ये करके जब देखोगे ना एक बार तो कभी भूलोगे ही नहीं कि green आया था. Getting the point? And if at all, if you get what were the other colors, red color, तो you know it is either strontium or calcium. अब crimson red है कि brick red है, उसके अंदर तो एक known salt उठाओ. बेस्ट क्या होता है, अगर मान लो आपको तो अननोन सॉल्ट मिलेगा, तो अननोन सॉल्ट में आपको रेड आ रहा है, आप कंफ्यूजन है कि पता नहीं ये कैल्शियम होगा या स्ट्रॉन्शियम होगा, तो उस केस में बेस्ट क्या होता है, शेल्फ से नॉन कैल्शियम का सॉल्ट उठाओ, उसको हीट करो, दोनों के कलर को कंपेयर कर लो. ठीक है, अगर दोनों का कलर मैच होता है, एक इधर बंसन में जलाओ एक उधर बंसन में जलाओ, ठीक है, तो अगर कलर मैच होता है तो इट इज कैल्शियम. देन टेक अ नॉन स्ट्रॉन्शियम सॉल्ट, अगर ये वो वाला कलर नहीं है तो यू कैन टेक इट फॉर स्ट्रॉन्शियम, बट अदरवाइज द कलर दैट यू एक्चुअली सी विजुअली योरसेल्फ इज द बेस्ट वन. मतलब आपको जो एक्सपीरियंस से जो चीज़ बार बार देखने से आती है ना, दैट इज लाइक समथिंग एल्स. I'm not going into details for this. Let's just note down the reactions for this. We have MgCl2 plus NH4OH plus you have, हमने अपना एक मैग्नीशियम का सॉल्ट लिया, उसमें हमने मैग्नीशियम अमोनियम हाइड्रोक्साइड डाला, उसमें हमने अमोनियम हाइड्रोजन फॉस्फेट डाला, HPO4 is 2 minus, so you have ammonium hydrogen phosphate is NH4 twice HPO4, that will give you magnesium ammonium phosphate. This is what is to be remembered. What is the white precipitation of magnesium due to? That is due to magnesium ammonium phosphate. Hydrogen निकाल दो, बस magnesium ammonium phosphate. So that is because of a magnesium ammonium phosphate plus 2 NH4Cl plus water, and this is your white in color. So this is like the confirmatory tests. Otherwise you can have the tests, sometimes even potassium and sodium are taken in group 6. Please make a note of that. Potassium salts and sodium salts, which are generally not given in your salt analysis, but K plus and Na plus are also counted in group 6. No specific reagents for group 6, you have direct confirmatory test. ठीक है, उसका मैं टेस्ट बताती हूँ. जैसे फॉर एग्जांपल इफ़ यू हैव टू परफॉर्म अ टेस्ट फॉर KCl, तो सॉरी फॉर सॉल्ट ऑफ पोटेशियम, उसको रिएक्ट करवा दो सीधा पिक्रिक एसिड के साथ. पिक्रिक एसिड इज योर, you know, have you done organic, you have phenol and 2,4,6 trinitrophenol is your picric acid. So you have NO2 and NO2, just easy to remember. This you will not be performing. I don't think they give potassium and sodium as far as I do remember. So in this case simply your H will get replaced with K. Here also note down, for a magnesium your H was getting replaced with your magnesium. Okay, so similarly here you have again your H getting replaced with K. So here it will be kind of an OK upar, and the rest of it remains as it is. NO2, NO2, NO2. Okay, and this will be yellow in color. See, colors you will have to remember at least. इतने ज़्यादा भी compounds नहीं है कि याद नहीं रख पाओगे, तो you can remember. This is yellow, and there is another test that you can perform for potassium. That is, you can add sodium cobalti nitrite. Add sodium cobalti nitrite, so that will again give you a yellow color, that is K3CO NO2 whole 6 times, and this is your yellow color plus 3 NaCl. This will also, so basically you add sodium cobalti nitrite to it and you again get a yellow color. So I mean for group 6, for magnesium the easiest test is you add ammonium hydroxide and you add your sodium, what is it, you add your ammonium hydrogen phosphate, and what will you get is your magnesium ammonium phosphate, which will give you white color. And you can easily remember the formula: hydrogen magnesium ammonium phosphate, ammonium is your NH4, phosphate is your PO4, magnesium is like Mg, so the final formula is Mg NH4 PO4. That's giving you white color, which is majority in majority of cases your precipitate formula is like more important. So you get Mg NH4 from entrance examination point of view. Which precipitate is due to which formula? So that is majorly. Nobody is going to ask you the entire reactions ki isme side products likho. Nobody will ask you that. So everyone is going to just ask you what is the main precipitate due to. So isme white precipitate is due to your magnesium, ammonium, phosphate. If at all you have group 6 mein now potassium and sodium also. Remember that generally potassium and sodium ka salts finally they turn out to be somewhere in yellowish tinge. ठीक है, तो अगर हमने KCl लिया, KCl is generally white in color, you make it react with your picric acid which is again white, it will give you a yellow color, मतलब potassium has reacted with your picric acid to give you a yellow color, and you can think of the compound which is have got formed, H getting replaced with K here. And then the last one that I wrote for potassium is your sodium cobalt nitrite, that is Na3CONO2, and then Na3 को replace करा दो, K and Na are like brother and sister, so they generally replace each other in almost all the reactions that you see. But I told you, why do we prefer sodium? That's like general knowledge, not for the exams. Why do we prefer sodium salts over potassium salts? They're less expensive. Okay, now a quick summary of all the groups that we've done. We've done only the analysis of the basic radicals. Let me tell you, I started up by talking about why basic radicals are your cations and not anions. I gave you the hint for that. You talk about any salt Na plus Cl minus, उसके अंदर जो cation है that is coming from the base, so cation is basic radical, and the anion is always coming from the acid, so anion is your acidic radical. So salts में हमेशा cation comes in from the base and anion comes generally from the acid. So that is one reason. Then we talked about 6 groups. I am giving you just half a minute. Go through the entire scheme once and we'll quickly discuss things related to it then. Can you please tell us the color of different color layer of Bunsen flame? See, when you talk about the Bunsen flame, it is like a normal flame which is generally the best color which comes is like blue color. And whenever you actually take up a paste and put it in it, then that blue color will always change into some or the other color. And just in case if any of the flames is giving you a blue color, it will be intensified further on. So it will just not remain the same. And let me tell you, whenever you do a flame test with either the platinum, flame test is done using a platinum wire. There is another test which is done using the borax bead. ठीक है, borax bead वाला colors I'll also put it on the board, and all these colors generally are the ones. Normally आप जैसे ही platinum wire को भी कुछ भी heat करते हो ना metal को, whenever you heat it in the flame, you know that the color suddenly turns out to be yellow. So those are the intensities which are generally varied. Otherwise we are not discussing each and every layer of the flame, no need. Because here for your salt analysis, what is more important is the color that you are obtaining after putting up your paste into it and the general color. ठीक है? Now for the borax bead also I am putting up. I think rather you go through and revise your first entire basic radicals. It is just a cupcake for about 10 minutes. So abhi I am giving you 2 minutes. Later on at home you can take more time. A borax bead test में, if the color of the bead, I am just putting it here. I am talking about now the borax bead tests. Borax bead test. Borax, I think it is this only. Put as E also sometimes. So color of the bead in the oxidizing flame. Now don't ask me what is an oxidizing flame. It is green in hot and light brown in cold. So this is your copper confirmed. Then you have pinkish violet. Whenever you have this color of pinkish violet, then it is manganese. Whenever you have a yellow, brown or a pale yellow, then it is your Fe3+. Whenever you have brown in hot and pale brown in cold, then it is nickel. This is another test that we can just add on. Ma'am, is charcoal cavity test a confirmatory test for an ion? Yes, you can consider the charcoal cavity test as a confirmatory test. In that case, see, remember that whenever charcoal also works on the tendency of adsorption majority of the cases. So, if a charcoal cavity test is performed, remember that the basic principle involved is adsorption only. Coming back to the borax bead test that I have actually put up here, you have the color of the bead that is to be noted. It's similar to your flame test only, which gives you a good kind of an indication for your nasal. So very first thing that we actually start up, you can just note down these colors. I'll quickly read them out for you. Green in hot or light brown in cold, that's copper. Pinkish violet, then it's manganese. If it is yellow, then it is iron. For the borax bead, I'm telling it again. And if it is brown, then it will be nickel. And now just a quick recapitulation of whatever basic radicals we have covered today. We started from our basic tests, and that was like, first was like you look at the color of the salt that will be provided to you. Remember that your salt should always be in the crushed form. Once you take your salt in the crushed forms, you get several indications from the colors which are actually given. You know that if it is blue or bluish, then it will be copper or nickel. Bluish green agar hai to it can be nickel. If you have simple greenish, then it may be nickel for sure. Then for sure you will have to perform the tests. Then if you have light green, it may be Fe2+. Alright, if you have brownish, then it may be Fe3+. If you have a dark green, it will be chromium. If you have light pink, manganese, and if you have a dark brown, I have told you that may be Fe3+. After that, you can look into the smell. If it is an ammoniacal smell, it will be ammonium ions. They belong to group 0. A direct confirmatory test can be performed by adding NaOH and Nessler's reagent. What is the formula for Nessler's reagent? What is the color of the precipitate? Brown. What is the formula of the compound? Forgotten. NH2 double bond HgO dot HgI. That is your brown colored precipitate. Then we move on to the group 1. In the group 1, we generally add your simple dilute HCl, right? In group 1, we are adding simple dilute HCl, and it may be either Pb2+ or Ag. Okay, so now remember that whatever white precipitate we get now will be due to your Cl. So it will be PbCl2 or AgCl. अगर वो soluble है तो PbCl2, अगर वो insoluble है तो Ag. फिर भी उसका confirmatory करना पड़ेगा. तो in order to do the confirmatory, we add potassium chromate, yellow precipitate तो हमारा lead confirmed. अगर हमें silver का test करना है तो वही potassium chromate will give you a brick red precipitate. So this is a summary of all the colors that somebody had just asked for. So if it is a yellow color, it will be potassium. Potassium chromate, if it's giving a yellow color, then it is lead. If it is a brick red color, then it is silver. Okay, silver का एक और test भी हमने then we did a potassium iodide test also. That will also give yellow color. Then we moved on to the second group immediately. Second group has our 4 ions in which we are including our Pb2+ from the group 1. अगर वहाँ precipitate नहीं हुआ तो यहाँ precipitate हो जाएगा in the form of its sulfide. पर वो हमें confuse कर सकता है. That will give us a black color. Black color will be due to 3. PBS or it can be due to HGS or CUS. तो हम टेस्ट क्रोमेट वाला ही करेंगे फॉर लेड. येलो कलर आया तो पोटेशियम लेड क्रोमेट कंफर्म्ड है. सो PbCrO4, तो दैट मीन्स लेड कंफर्म्ड. ठीक है, अगर वो मतलब येलो नहीं आया तो इट मीन्स इट इज आइदर HGS और इट इज CUS. सो फॉर CUS एंड HGS, अच्छा अगर फॉर CUS एंड HGS अगर है तो CU में हम अगर एक्सेस ऑफ अमोनियम हाइड्रोक्साइड डालेंगे सो वील गेट अ bluish white precipitate. Very good. We'll add ammonium hydroxide to it and we'll get a bluish white precipitate, and that precipitate can then be made to react with potassium ferrocyanide to form copper ferrocyanide, which will be chocolate brown in color. Okay, that will be chocolate brown in color, and that is because of copper ferrocyanide. All of you all know that. Once that is done, after moving ahead with copper, then we move on to our next, which is mercury. From mercury, we have seen that mercury is not, copper is soluble, by the way, CuS is soluble in 50% HNO3, but HgS is insoluble. तो ये भी एक डिमार्केशन हो जाएगा. मान लो लेड नहीं निकला, तो अब दो बचे थे, मर्क्यूरी और कॉपर. तो अगर if it dissolves in 50% HNO3, it is copper. If it dissolves in aqua regia, then it is your mercury. And for mercury, we have done a test which actually, again, what you can do is you can add HCl and HCl to it. So HCl पहले add करेंगे तो HgCl2 बनेगा, which makes it soluble. Once it gets HCl and HNO3, that's aqua regia, I'm sorry. हमने क्या करा, अपने Hg को लिया in aqua regia, it gets dissolved. Now we'll add a little bit of stannous chloride to it, SnCl2. उससे हमारा पहले Hg2Cl2 बनेगा, which will be white in color, and then it will further react to give you Hg, which will be grey in color. तो white precipitate खड़े खड़े थोड़ी देर में क्या हो जाएगा, grey. Alright, after that, what are the ions now left? Cadmium is the only one which is left. अगर हमारे पास pure yellow color आ रहा है initially H2S पास करते ही, तो yellow. That can be a happy note because वो बिल्कुल different है, तो उसका confirmatory आराम से हो जाता है और जल्दी जल्दी भी निकल गया group 2. So cadmium में you have the confirmatory test also of the passing of the H2S test, and I had given you one or two more extra tests in which it gives a white precipitate. I told you white may be a little confusing, so I always rely on the H2S. So now in the next case, we move on to now group 3. Group 3 में you have aluminium Fe2 plus and Fe3 plus. Remember, in all these three cases, you will get three different colors: white, gelatinous for aluminium. Confirmatory for aluminium is blue lake. ठीक है, test. फिर उसके बाद next, उसके बाद you have a dirty green precipitate, so then that means Fe2 plus. If it is a reddish brown precipitate, then it is Fe3 plus. Fe3 plus का confirmatory test can be that of potassium ferrocyanide. सिर्फ मेन रिएजेंट याद रख लोगे तो काम हो जाएगा. एंड व्हाट यू गेट इज अ फेरिक फेरोसाइनाइड व्हिच इज प्रशियन ब्लू इन कलर. फेरिक फेरोसाइनाइड व्हिच इज प्रशियन ब्लू इन कलर. देन वी मूव्ड ऑन टू द फोर्थ ग्रुप. अगर आपका नहीं आया तो डायरेक्टली उस सॉल्यूशन को आप लोगे जिसमें NH4Cl और NH4OH डाला हुआ था, उसके अंदर अब पास करना है H2S. सो वट एवर कलर्स ऑफ द प्रेसिपिटेट नाउ यू गेट विल बी ड्यू टू योर सल्फाइड, एंड द कलर ऑफ द प्रेसिपिटेट इन जनरल विल बी ऑफ वाइट और बफ कलर्ड. वाइट कलर में हमारे पास आ जाएगा Zn, Mn और कोबाल्ट. बफ कलर्ड अगर आ रहा है, बफ मतलब पिंकिश बफिश, थोड़ा सा गंदा सा. बट अगर बिल्कुल ही डर्टी वाइट है तो जिंक. जिंक गिव्स यू अ डर्टी वाइट, और बफ मतलब थोड़ा सा बिटवीन, इट इज लाइट पिंक, लाइट ब्राउन एंड वाइट का कॉम्बिनेशन. मिक्स करके देख लेना ऑन योर पेस्टल्स. So then you will have that color for your manganese, and then you can perform the test for manganese. I told you, एक तो bromine water डाल सकते हो, दूसरा उसके बाद you can even perform a PbO2 test in which you get HMnO4, that will give you a pink color, and that also will give you a pale pink color. And for zinc you can actually add white precipitate to NaOH. अगर वो excess NaOH में soluble है तो वो zinc है, अगर वो नहीं soluble तो manganese का टेस्ट करो. अच्छा, manganese का टेस्ट करने के बाद next we move on to our cobalt. Okay, now for the cobalt what we have is you take cobalt and nickel will be taken together, because again we'll make use of aqua regia. अपना sulfide लो, उसको aqua regia में you will dissolve it, and on dissolving it now you are segregating it into two parts. One part will be that in which you add amyl alcohol and SCN, that is your देख लो SCN भी ammonium sulfocyanide. Okay, when you add ammonium sulfocyanide you will get a blue color which is suspended in your alcohol. This will be because of your cobalt sulfocyanide. And then you will have your nickel का तो it's like famous the DMG test, that is dimethyl glyoxime. It will form some kind of a chelate complex wherein you have a rings getting formed, so that will be highly stable, and that is what is in color, that is a little sometimes referred to as bright red also, sometimes referred to as bright pink also. तो दोनों का जो combination है वो समझ लो, and that will be nickel DMG, and that's used as a dye. So that is very commonly used as a dye. So that is why an important example. Then we move on to the fifth group radicals. मान लो H2S पास करने पर नहीं आया तो हमने group 3 के जो reagents थे NH4Cl and NH4OH, we'll add ammonium carbonate to it. So whatever precipitate now we'll get will be white in color, and it will be because of the carbonates which will be formed. कौन कौन से है? बेरियम, स्ट्रॉन्शियम, कैल्शियम. मैंने कहा ऑर्डर में याद करना. बेरियम, स्ट्रॉन्शियम, कैल्शियम. बेरियम के लिए confirmatory you will add potassium chromate and you will get barium chromate which will be yellow in color. Strontium के लिए you will add calcium sulfate, it will give you SrSO4 which will be white in color, highly insoluble. Then you will have your ammonium chromate, dichromate or chromate? I forgot. It is ammonium chromate. Ammonium oxalate, I'm sorry, somebody confused me here. We add ammonium oxalate, and whenever we add ammonium oxalate to that, then again we get a white precipitate which is mainly because of our calcium. Usse bhi if you are not happy, then you perform the flame test. In the flame test you get an apple green color which is like a perfect confirmatory for your barium, crimson red for your strontium, and you have your brick red for calcium. Then last but not least we come on to the last group. अगर कुछ नहीं निकला last में ज़रूर निकलेगा. That will be your group 6, in which you will be generally given magnesium, in which you add your excess of NH4OH along with ammonium hydrogen phosphate, and the color that you obtain will be white. That will be because of magnesium ammonium phosphate. कुछ भी magnesium ammonium phosphate, all right, and that will be white in color. And then I told you that even sometimes potassium is taken in group 6, for which I have given you 2 confirmatory tests, and if you get thorough with all these you will just get full marks in your basic radicals analysis. All right, all the best, do well, thank you.